start on YouTube. That'll come in a second there. I guess my bitching will not make it to YouTube, huh? I'm feeling kind of run down today. I don't think I really slept yesterday. Last night, rather. Into today. I'm going to try to get a nice clean bed tonight so I can actually... Oh, wait. What the heck? That's not my title. Oh, no. Oh, man. Okay, well, now I've got to... Gotta grab the YouTube title. Shit. That title's gonna permeate now. I forgot to do that. That's on me. Add to queue. No. There we go. Title fixed. Now everybody's got a bad title in their doobly-doo or whatever the hell emails people get from this stuff. Stupid. That was dumb. Pop this out. Pop out. Wish I could automate this. Maybe I can. Maybe I just need some slightly different tools to do that and get all my windows into the right spots and stuff. I should look into that because I think there's some pretty powerful tools for that sort of thing. Get that out of the way over there. I got all 4 of my viewers are here. Sweet. How's everybody doing today? It's Thursday. It's Thursday, and the house is completely full of people, and so I'm going to be a little bit quieter as we proceed. I want to build something. I think we should probably clear off the desk. That'll be sort of the pre-stream, and then I'll get the stuff that I need to build this thing, and then we'll talk about it when I begin stream. Until then, we'll hang out and have stream start soon right over there. Why is that up if I'm streaming? Well, because... I don't know, not every human activity needs to be monetized these days. No, it's just to let people gather ahead of ahead of stream. So I get people here for when I actually start. You think, but the stream has already started. Yes, I hit the start button on the actual stream controls, but that's not when the stream starts. When I start doing stuff is when it starts. It's a common confusion that we get here, and somebody's probably going to mention it later on because right now nobody's watching. That's the very reason that I do this, because if I explain Start Soon now, somebody's going to ask why Start Soon is running later on. And it turns out the very reason that I have a Start Soon up is because of that question. It's, oh boy, it's like a catch-22. This thing worked out really well, this VCO. The only thing that I need remaining to do on it is to build an LED engine. And just to make sure everything's functioning properly, I also need to tune it. So we will do that. I don't know if we'll do that Friday. I don't want to do a coding heavy stream again with this thing, and we need to keep the variety going. I try to do variety, but when we need to focus on a project, we do. This will get Julian and Dave back in here. I did not order any additional RP2040s, ZOWs. I need to get a couple more of these because I want to build a lot of these VCOs, and if I give Julian and Dave one, I can build up the ones I have, do the little fix job, make sure that the power sockets go in upside down, and clip the lead to the LED of the button so that it works. All of those edits are actually in CAD, but before I order more boards, we need to build up the Chord VCO, and the Chord VCO is going to be its own software question mark. And so before I even get into that Chord VCO, I want to make sure that my LED to communicate statuses works, and I've got all that code ready for it. So, and then we have to physically build and get this circuit board working in case there's an additional mistake on it. So that's kind of where we are with this stuff. I'm going to put this aside, and we're going to clean the desk off because we're going to do other synthesizer stuff today. I really need to set up like an additional synthesizer input, don't I? So you guys can hear these tones a little bit more clearly. I guess that'll be for another day. For now, I will leave this speaker setup plugged in, but maybe I should move the speakers up or something. Keep them off. Maybe I can just stick them up here so they can hang out. I'll put one on top of a hard drive. That's a great place for a speaker. Of course, these are getting in the way. What up, Jojo de Yodio? Jojo de Yodio? Babbity. Oh, motion detected at the front door. My dog goes nuts. Yeah, I don't really know where to put these speakers. There's like no space for stuff like this. Put them under here. There's barely any room under here, but maybe I can just stick them in this area. I don't know. Well, we're probably going to need the bodge wire. Well, yeah, we are going to need the bodge wire. I'll have to pull that down later. Behind a screen is a place for a speaker. That wouldn't be too bad. But we got to plug into these speakers. These speakers are specifically to test synthesizer stuff. And I often have to use them like as an audio source when I plug into stuff. That's why they exist. So they need to be kind of front and center, along with my attenuator. Luckily, this thing's passive. Should build a little box. Build a little box for little synthesizer stuff. All right, let's see. Wait, is this? Oh yeah, this is the whole playlist. Just sounds like it played the same song twice. Back down here. Okay, so clean up, clean up, clean up, clean up. I feel kind of weird today. I think I need to hydrate. Drinking seltzer. Switch over to water later. Now the Node-RED stuff with Twitch, I've seen a little bit of it. I need to make sure that nothing is going to dox me, dox my stream key or anything like that. And then I got to find out. The one that I found looks really comprehensive. It's got like the whole Twitch API in it, but I don't know how to install it. So I need to look at Node-RED a little bit more and see if I can make a robot and connect it to my chat. The only reason I have my monitors mounted on one over the other is so it doesn't interfere with my speakers. What? That's the only reason you have the monitors one over the other? I guess, you want an unhindered path from the speaker to your ear. That's actually, yeah, that is a good thing. I got mounts that I attached to the Burn the Subs board. So here, maybe I can show it without showing you how much of a slob I am. So, everything is so messy. There's a broken RC car and just all this bullshit. But you can see over there that the monitor is actually mounted to where Burn the Subs is, which is a backdrop for my desk. And so I've got that beautiful path. Yeah, HS7s, and then the subwoofer down there I actually got from a friend, and he had it intermittently cutting in and out. And oh, you have the same monitors. I like them. They're like a workhorse. They're like a one-for-one reproduction of audio, which is what I like. I like my Sony MDRs. I like my workhorse style audio equipment because the dynamics of the sounds that I'm hearing are actually coming from tubes. I used my Donald Trump check to buy shit audio gear, and I bought a tube amp with that. And so I've got vacuum tubes that are creating the sound, and the HS7s are just reproducing that sound. I had a really bad problem with ground loops though. I had to get an isolator for like a XLR isolator to put in there. Otherwise I got ground hum. I could literally hear myself moving my mouse on the monitor. It was making like noises as I moved the mouse around. So that isolator wasn't cheap, but I used it and it worked perfectly. We were going to take the case for that isolator and produce my lavalier microphone filters in physical form instead of in VST form like they are up here. That's the VSTs for my audio filtering, but I wanted to make a little box that has filters in it. Now that's not out of the realm of possibility of a thing that we might do in the future, but for now it's just I've got too much going on to reinvent some of these things. Those are those test cables. I love these BNC to headphone cable to mono 1/8 inch. I love all the stuff you're doing. It's entirely motivated by my own interests, and I do like all of the audio stuff, and I'm getting into it. I don't know much audio stuff. I know this stuff. I know programming microcontrollers, but programming microcontrollers do audio stuff is getting kind of interesting. Same problem, at least 5 running projects. You know, keep the variety up in order to keep your brain from getting annoyed. But at the same time, I gotta get some W's under my belt. That VCO needs one more stream for me to complete it. But we've been working. It got up to part 10. Like part 10, people like are not interested anymore. So some people are. Some people can tough it out, and I'm thankful for them. But my streamer brain is telling me that I need to get the hell off of audio for a little while. But we've got, you know, all these projects are also just constantly floating around. Floating around, floating, they're circling the drain. They are floating. Nobody will get your Hackers the Movie references, bother. It's so warm over here. I'm gonna get like ill. It's too warm. Gotta pack all this stuff in. I don't get it. I got not a decent bedtime, but I feel like I was hit by a truck. I must have snored. That must have been it. Fucking weight-related sleep apnea. I hate it. Are we gonna breadboard? I think we're gonna jump to soldering. I think we're gonna jump straight to soldering. Because I've already almost got the whole thing set up. Also, we don't have, I don't have through-hole 1N4148s. I don't have through-hole diodes. I only have surface mount ones, so we gotta live with that. Pair of tweezers, these go back into here. I found my other pair of tweezers. They were in the big tool drawer. Let's see here. I've tried making lists for projects, and it just hasn't really worked. Like, here's the list of projects. Oh no, it's depressing. I keep saying that we're going to work on Burn the Subs, and we are, but I did want to give that, the laser water cooler setup, I wanted to give that some time to marinate because I want to make sure that it doesn't leak after time, which is absolutely a thing that could accidentally happen is, oh no, it looks like the epoxy just comes off now. You know, I want to give that a little bit of time to just kind of sit, and then we'll test it out again before we put the new radiator on and all that stuff. Gimme. Node-RED is probably going to be the next thing that we focus on, and I'm going to get this thing working again. Everybody's saving up their channel points. They're going to have like 10,000 farts, but it will also open the gateway to new and unique ways to fart. Not really. New and unique ways to control things in the shop. Why is this magnet over here? Oh, there's a tube. There. Twist tie. Did I use up all my twist ties on something? I thought I had a whole group of them. There's one back there that I can't get to. But like when the cable really wants a twist tie, you know? This thing wants a twist tie. I gotta find one. Twist, and a tie, and a twisty tie. Tying a twist. Tongue-tied. Twist-a-ma-digger. Twisty tie. These are garbage. Into the bin. No room. I have no room for superfluous things. I must keep throwing things out, compulsively even. I just ordered a little bit of BNC hardware to make sure that I'm able to set up the tests slightly easier, so they're not... here we go, I found one. All it takes is digging a little bit. Gotta lurk while I cook? Alrighty, have fun. Man, I can't post anything to my food section without people making fun of me for some reason. They're always mean to me. I think it's because they're familiar with me and they wanna bust my balls a little bit, but it feels rather personal when it's something you've cooked. Like, I'm okay with the ball busting if it's like, you know, just joking around normally, but every single time I post some food in my food section, I get negative feedback, and it's like, all right. I know where it's coming from. I know it's coming from a place of love, which is cooking is from the heart, but it just gets, it's like, why would I post something in my own food section if I know that somebody's going to come in there and comment on one thing that I did differently? Like, I made Swedish meatballs, and the jam, since we didn't have lingonberry, we couldn't find it in time, we just had strawberry, I think it was preserves or jam or something like that. And I know Turts means the best, and he's a nice guy and all that stuff, but it's just like immediately getting a negative feedback comment on something that I cooked is just not encouraging. I don't think he knew that would be my reaction to that, but it's literally every time I post something, somebody's got to make a comment on it. It's like, why do I post anything but perfection? Only the barbecue stuff kind of defies commentary. This is ruining a perfectly good potentiometer, having it on this big knob here. So I need to get this off of there, because otherwise it's breaking the pot's leads are all messed up. Oh yeah, the grub screws behind rubber. So I gotta somehow get the rubber off of here. Feels like it's been the same song 3 times. Let's jump ahead a little bit. Is that just the theme for the whole soundtrack? I thought there were some slightly different tracks in here. Yeah, there are different tracks. It does kind of have a banger of a soundtrack. It's just when you listen to them in order, the same song keeps coming up over and over again. The same theme, the same progression. Melody, there we go. That's what I was looking for. Same melody comes up over and over again. All right, so that goes into storage, I guess, and then the potentiometer. I'm just going to toss it in the bin right now, but my collection of knobs. I need to order more of the knobs for the synthesizer itself. Those are an Alibaba order, and I ordered a ton of them. I need more. I don't have enough to cover everything. I didn't tune clouds. I don't know what clouds will do. We might bring the whole rack over here, and I might go through these modules and kind of rearrange things. If we have time. We probably don't. We probably don't have time. All the times that I've taken to like actually physically build something on perforated prototyping board, it takes forever. It just takes a long time. Just because we're being careful, we're trying to be neat about it, and often a lot of the time is spent looking for parts. So these are a little bit more straightforward though. This is a Hajiwo circuit that we're going to build. It's complicated, but I do have all the parts for it. It's just one of those things that, you know, you stock up on parts for. I'm a little concerned about the 1N4148s. If I don't exactly have 4148s, I'm going to have a little bit of trouble with this. Yeah, we'll burn that bridge when we get to it. I thought I'd ordered a bunch of 4148s. The thing is, this is going to take 12. 12 plus. Oh, yeah, more of this stuff that's in the way. I would love to build this thing on a big circuit board, but I think we should utilize, I'm going to utilize the ones that we built for the VCO. I don't know if we can do something with the switch, so I've made a front panel already for this that says diode on it, because this is a diode ladder filter. So we're going to make a diode ladder filter, we're going to get the switches and stuff off of there, and then I guess those 3 Thonky Kongs are going to hold up the entire thing, which it'll make it a big overhang, but I like that little plucky bass that they have in these songs. Let me just like load everything up onto this heatsink that I need to organize later. I don't know if you guys saw, I forget what day it was, but I took the RC car out for a spin, and you know, big giant blueberry shaped guy, big fat guy, like a kid's drawing with just arms and legs, driving around a little RC car and going hee hee hee. But anyway, it's like super duper fast, and it ended up tumbling. And since then, every time I walk the dog, I'm looking at my feet, hoping to find the spring that I lost, as well as the pin that goes into it. Now, both of those were $2 purchases to get more parts for both of those. And then another $2 to get the A-arm that broke. But it tumbled, and one of the wheels that didn't have anything protecting it hit the ground hard enough to pop a joint. And then once it pops a joint, the spring is free to go, and the little rod that broke the joint, and that was the piece that broke it, was free to go. And I have no idea where they are, because all that pavement out there is all light gray, and there's no way to see anything on it. So it is gone. It's gone as gone gets, I believe. So I've ordered more parts. They're on the way. Yeah, here's the good stuff. This is the real hit stuff that from the soundtrack. Soundtrack is awesome. It'd be kind of cool to be able to make stuff like this on the synthesizer. I don't think I'll be able to make exactly this sort of stuff without a significant number of samplers. You never know, though. You never knew. God, my guts hurt. I don't know what the hell's wrong with me today. I think my chest's kind of gotten into a state because of the rain. Just from having broken my skeleton completely. All right, I'm pretty clean. Looking pretty clean. Let's get the fart box fully out of the way because that'll be something that I repair later. How much dust is on this thing? Yeah, not that too much. This is just like an odd, like, you know, if you're camping, you put your cell phone on something like this. And I bought these a long time ago because I was camping and I put my cell phone in something like this. They're really cool. These otter boxes, they got like a net inside of them and all that. But I wasn't doing anything with them, and they're great project boxes. So we cut a big speaker hole in it, and then I cut a big vent hole in the bottom so that air can get in and out. And it turns out this is a very good resonance chamber for a Harman Kardon speaker. So that was pretty cool. And then I did one of my early 2-filament prints where I switched from one filament to the other and then back in order to create the illuminated channel point fart box text. Only problem is the LEDs inside of here we didn't really budget for properly, and they get hot, which means it shows up on thermals though, which I guess that's an advantage. All right, I'll put this over here. My kidneys hurt today. I guess I gotta hydrate a lot. Flush them out, flush them out, flush them out. I also need to work out with my doctor. Not like pump iron. I mean, like, I need to work some stuff out because they have been routinely failing me lately. I'm supposed to get an insulin prescription, and I didn't. And then I go to the pharmacy, and they're like, you need to have your doctor talk to insurance. And I'm like, sure, that's an easy one to set up. So I've called them multiple times to try to work things out, and I'm supposed to be on a blood pressure medication that I'm not getting. So I think my blood pressure's been kind of killing my body lately. I have like super duper hypertension, and it's hereditary. So it's hereditary, and I'm also a fat person, so like those don't help one another out. My high blood pressure relatives. Cool. Let's get the design open on the computer. I might as well like start the stream because I guess I kind of now that I've cleaned the desk off, I kind of want to focus on this. We didn't get through any of this soundtrack. I wanted to listen to it. You know, pause. Okay, let's see. Face cam. Bada bing. How you doing? I still haven't gotten a haircut. I meant to. I really meant to, but I've been trying to get other stuff done around here, and I've had to pick up the slack for a roommate, quote unquote. It's my dad. He went through some abdominal surgery. They operated on him with a robot. He didn't get to see the robot, which is annoying because it would be really cool if he did. But anyway, so he got operated on and he's totally fine. It's just that now everybody's home and I have to kind of pick up the slack. So today was garbage day and I did quite a bit of lifting there, as well as wrangling the dog and all that fun stuff. So yeah, I've been trying to get to everything. I've still got taxes that I gotta do. I think I have to do taxes, and then yeah, I gotta get a haircut. I gotta sort out all my prescriptions. I'm just overwhelmed with IRL. So when the push comes to shove and things stack up and you get overwhelmed, it's time to build a circuit. And the circuit that I've decided to do is for the synthesizer, because this thing, unbeknownst to me, this synthesizer here has been nothing but educational in terms of circuits and analog stuff. I've done a little bit with digital to analog lately, and you know, I've mostly been comfortable in my little water pool of my tidal pool of digital. Digital is very easy to do, ones and zeros and logic. But analog gets a little crazy. Things get a little weird when you get into analog, because analog is swinging voltages and feedback loops and things like that. So there's all kinds of pitfalls and just testing that you do, because you mostly exist in the real world with analogs. So my dog is just going to continue to bark. She's a very loud dog, and I think her friends are around or something. So sorry about the woofing in the background. But anyway, so we've been learning more about analog, and in the process of learning about analog, thanks to Speedy Cat actually, yeah, the talk in the background. I've seen a video recently where somebody buys old Operation Robot tools and builds the controls with Arduinos around them. That's interesting. That's a weird one. But anyway, we've been learning how the modular synthesizer goes together and functions and works in analog space. The modules that I built that have been analog purely, I think none of them work. None of them work. Most of them don't work. I've tried to use the right transistors and stuff. I think there's this end push to tune them. No woofing coming through. She's been quiet for the past couple minutes, but it will continue. She will go back to woofing. Woof, bark. So anyway, yeah, maybe it's the final push to get things functioning that I've lacked, but I don't know, man. Like, I guess I have to keep doing analog stuff and keep, you know, just basically holding my face in the puddle of piss that I created in order to make sure that I know what I'm doing and that I can follow through and finish these things. It's exposure therapy, right? So that's the philosophy behind what I'm doing, is exposure therapy. That's a lot of emotes. So anyway, what I guess I'm gonna do is build a circuit. And what circuit do I want to build? Well, I've said it before. I need more, what do you call them? Filters. I need more filters in the synthesizer, because otherwise it's just like notes coming through. It's just beep boop bop beep 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 bop, right? You want weird dynamic filtery stuff to go on, right? You want cutoff filters and to control those with voltages and low frequency oscillators and things like that. So in the quest to build the synthesizer, we need a filter. Now I already have Clouds, but I don't know what Clouds does. It's the one that's sitting there in front of everything. I think we got Clouds working, but I don't know what Clouds does. So instead, I'm going to go the direction of Hajiwo. And Hajiwo is a YouTuber that Speedy Cat threw at me. And what Hajiwo does, Hajiwo is Japanese, he creates cheap modules. So a 450 yen homemade voltage-controlled filter. And it's a diode ladder. How that works, I have heard. I watched the video twice. Mortis Klein has wonderful YouTube videos about exactly how things like this work. I didn't understand a damn word of it. I kind of followed along a little bit the first watch, a little bit more the second watch, but I'm not absorbing it and I don't know what that means. So, I mean, the circuit is relatively simple. Instead of op amps, we are using transistors. Hajiwo opts for the 2SC1815. The ones that I have, BC 548 and 547, are equivalents. They've got a little bit of a higher voltage range, but they're good for audio. And I only know that because I Googled around. I Googled around and I found people who knew synthesizers talking about them. What transistors do you guys like to use? And somebody said, I like the BC 547 and 548. And I'm like, I got those right here. Here they are. Look, I've got them. There they are. Look, that's the guy. That's the guy. Anyway, so yeah, so I have these. So at least we can put in these 4 transistors that Hajiwo is using in lieu of op amps. Apparently a diode ladder filter uses op amps in some capacity. I'm going to go with Hajiwo's circuit. I'm going to keep with Hajiwo's circuit. Before, we modified Hajiwo using mutable instruments circuit design. And the mutable instruments circuits take in synthesizer volts and they turn them into 0 to 3.3 volts for the microcontroller. I think that's brilliant, and we went with that. Instead, though, we're going to go with Hajiwo's because this is a filter, and the filter can be a little bit dirty. That's a good thing. If the filters doesn't quite work right, it's great. I wouldn't intentionally, like some YouTubers, I don't intentionally seek out the jank, and I don't intentionally try to make things always explode. And while I should, that would be good for views, I don't want to breathe in chemicals. I've had enough exposure to solder over my entire lifetime that I don't want to blow up capacitors There was a video that I saw recently of, and it wasn't one of these YouTubers that blows stuff up. It was probably from a factory, and it might have just been like a one-off test, but they had like an air cage and everything for it. But they were intentionally blowing up capacitors to see how they responded. Some of them just would off gas. Most of them would just pop normally. The exploding capacitor that we had in here was because I was running 50 volts through a 30 volt capacitor. So there's a significant amount of volts, and my new power supply, the one we built, it allowed for a lot of current to get through. So that thing heated up fast and it detonated. Like, I was actually finding cardboard a week later, like on pieces of the desk, because it violently detonated. So like, I don't seek that stuff out. But if we do build this filter and it's got a little bit of jank, that's going to be good. So new project, I guess. So I'm going to copy this, copy the image, and I'm going to go to MS Paint, because MS Paint is the MS Paint is the best CAD program that we have access to. And in this paint drawing, I'm going to paste the entire diode ladder. We will then save this. Not paste. Oh yeah, the icon that all the kids don't know what it is. I've got a bunch of those in the shop now. Save this to our file server under a new folder, but in the, where's my file server? Desktop. Boop. And then the stream projects. Where's the project? I need to clean out this computer. I need to clean out this computer. Why is it not? Oh, did this computer reset? This computer reset. Cancel. All right, hold on. I got to log into the file server. Wait, but then no, I should totally be in here. Maybe I just have to go through the network. I have to go through here. Yeah, okay. The SMB share from the file server is a little weird. Diodes for distortion, that I do get, but for filters, yeah, so from what I understand, and it's not much, the way that they're using the diodes is as variable resistors, because the diodes have a little bit of leakage. And so as you change the voltages, of course, you know, diodes respond, because they're pieces of silicon, they're not resistors. So like 1N4148, in other places you use them because of the voltage and how they drop off, or sorry, how they limit and switch. But when you use them as a variable resistor, you're taking advantage of the curves that represent how the diode functions, and it turns into kind of a variable resistor of sorts. Now, Mortis Klein explained this, and it literally just fucking like ejected my ear, and I just have no idea. I don't know. I absorbed 5 or 6 words from the overall explanation from Mortis Klein, but it was a very good explanation. It's nothing against the Mortis. I just am dumb. So the paint document will help us out. We can mark down what we've built and hopefully get this thing on the page fast. I'm hoping. I mean, I could breadboard it, and that way I could come up with my own like tune stuff. You know, oh, I like this, I don't like that. The solderless breadboard allows you to have that flexibility with the circuit. My problem is I don't want to build 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 diode adapters, because I don't have the through-hole diodes to make this. Which, boy, you know, that would be nice to make sure that my circuit works. But oh well. So we're in Stream Projects. We're going to Synth. I'm making a new folder. And this would be diode ladder. And this one is diode ladder.png. And we're going to use this as our scratch pad. As I build the circuit, I will mark off in red what I've done, what I've built. And that way we can keep track of where we are. I can cross things out as we get to them. Capiche? You are just having the time of your life with emotes, aren't you? All right. All right. Let's get started, huh? Where did everybody's badge stuff go? Oh, no, you're not even subbed. Well, whatever. Interaction is interaction. I won't say no to that. So here's the deal. So we tried to make the Hajiwo circuits, the voltage-controlled oscillator, with perforated prototyping board, because it's Hajiwa, right? He's got these cheap circuits, everything works, and it's so stupid inexpensive. But I gave up midway through building them, and I popped a neuron. The vein in my forehead started bulging because I got really mad because this is like a little bit more difficult than I had anticipated. Circuit was a little bit more complicated than I had anticipated, and we didn't have room for anything to go on here, and I would have had to do all kinds of weird stuff in order to get it working. So what I decided to do was just go straight to a printed circuit board. And of course there are mistakes all over the printed circuit board, but that leaves me with these parts left over. So let's modify this one. Let's get the switch and the button out of here, because we don't need it, because it's just a filter, and then we can put it back on here. My dog is still barking, and it's starting to really get me mad. Design the thing, order a PCB from the manufacturer, and then see that I have the wrong labeled net somewhere. Well, you know what? That didn't quite happen, because Fusion has a lot of really good checks that kind of keep you from doing dumb stuff. But at the same time, oh my God, I wish my dog would just stop barking. I'm about to just yell. I think that's what's going on upstairs. I think they are yelling too. She, for some reason, she got a bee in her bonnet and is just barking at everything that moves. It's okay. It's okay that she barks. It's just, you know, she's not supposed to do that in the first place. It's not just to keep quiet for stream, because it's actually cute if you can hear the barks in the background. It's just when she's barking, she's not being a good girl. She's been a very good puppy. She's been a very, very good puppy. Oh yeah, thermals. Bonk. Oh, I didn't, okay. It's toggle. There we go. Well, yeah, all the checks, for my experience using Fusion, all of the checks are worth, well, they are, no, listen, the checks are extremely important, because this would have been riddled with mistakes if it were not for the checks. Mislabeled nets, I don't really get. More of it is how I mislabeled positive and negative, because I assumed I knew what I was doing with the power plug. Luckily, the power plug is symmetrical and you can just flip it around, but the power plug was done wrong in the schematic. In addition to that, the positive and negative of one of the op amps was done wrong, because I didn't notice that they were flipped in place. Because you could do that with op amps. If your circuit's going to look better with the plus and the minus flipped, you flip the plus and minus, and I didn't notice that. And then what was the other one? What was the other mistake that I made? Oh, and the button. The button, I assumed I made a part for the button, but I assigned the wrong pins on the button. I should have double checked my work. And so I had to fix the part, and that changes the wiring. So yeah, how's her leg? She's still limping. She's still limping in exactly the same amount as before. We may have to get surgery. Surgery is very expensive if that dog is going to walk properly again. She needs to rest, and it's very, very difficult for a young corgi to rest in a neighborhood full of dogs. I love this neighborhood. It's full of dogs, but giving our puppy a chance to heal is very difficult. Oh my God, dog. She's still barking. I don't know what the hell is going on out there. Oh, you know what it is? It's trash day. That's what it is. The people collecting all the recycling and the garbage she's having it out with, and then the people in the house are reluctant to take her for a walk. Just shut her up. I'm like, for some reason, they don't take the dog for walks during the day. I'm the only person who's capable of this. I don't know what the deal is with that. I'm tempted to take the 3 plugs off of this board and transfer them to another. That probably means that I should have saved that in the state that it's in. We'll try to use this board. I think we'll be okay with it. It's just with some of the holes have been expressed. They've been embiggenated in order to. Actually, we shouldn't waste solder braid on this. We should use the sucker. When we use the sucker, we should probably use magnification. Look at that. We're using magnification for the first time in like a month. Somehow I'm capable of getting structure to my parts libraries as a result. That have a lot of project-related libraries. Oh, that's bad. Yeah, what I need to do is sit down with like a pot of coffee and focus on redoing my libraries. What I have is what I call Jesse, basically my first name and then the wrong year. I got to make Jesse 2023. It's always 1 year behind of the current year. but I need to remake it and pull all of my good parts into it, because the one that I have is Jesse 2018 from before I was using Fusion 360. So very few of the parts have 3D models associated with it. And I need to go through thing by thing and make sure that every single part in that library has a 3D model that's associated with it, like a proper one, which is not difficult to do when you get the workflow down, but it is work and it doesn't really pay off until I go to build something and I happen to have all the parts in the CAD program and I just sort of throw it all together and order a PCB. I would be capable of doing that very rapidly if I fix my library. And I've learned how Fusion handles the parts and stuff. It makes a huge mess of 3D models and stuff. But if I can cordon that off into its own folder and finally just like finish my libraries, then when I go to make a new part, everything has a place to be. So that's something that I really need to concentrate on. And I think there are like, I think the value in that is super high. If I could get clients, if I could actually get clients that trust me to build circuit boards and I have this library of common components, I think I could stand to make quite a bit of money. Finding the clients is difficult though, and I'm not about to hop on Fiverr. How are you? What are you working on? That's none of your goddamn business. I'm just kidding. We're working on a voltage controlled filter, a VCF. This is another Hajiwo design, but this one is mostly analog. And so we're reusing some of the stuff we built earlier, which was the voltage controlled oscillator on the perforated prototyping board. I'm right now desoldering the switch and the button because they're not in use and we need all these holes. The filter is a diode ladder filter. How does that work? I don't know. I don't actually know. I've watched a couple of videos on it. Mortis Klein has a really good video that Pyro linked in my stream projects section. And I watched it twice and I still don't know how this thing works. I'm doing okay. I don't feel like I actually slept last night, which is always bad. Like the poster boy for sleep apnea, and yet I don't have a CPAP machine. Let's see here. Somehow incapable of getting. Oh wait, this is the same comment. I have one comment per hour. It's I put a hard limit on it. Nobody's allowed to comment on my stream. There will be no comments. One comment per person per stream, and I have 2 viewers. All right, so diode ladder filter. Let's get a picture on, what's up, Mahalo? Request for comment. Well, there you go, you used it up. Save image as, let's put this on the desktop. I'm gonna put a picture of the circuit up on screen. Desktop, and this be, wait, it wants to save it as a WebP, what the hell? I guess what I can do is I can take the MS Paint and I can take this all the way over to here. That I could make, no, I'm not gonna make the background clear. Desktop. Save that. All right, what's going on over here? What are you guys talking about? Wayne Johnson is gone. Hope your weather isn't complete balls. It was. It rained for like 5 days, and now we finally have a little bit of sunshine, and I'm locked indoors. I went outside with the dog and just stood in the sun for a little bit, like, oh my God, finally. What's the conversion rate of fart points to comments? Well, right now, there's a 0 somewhere in the polynomial. Somewhere in the multiplying, there's a 0, because the 0 times 0 is 0. Dat eats! Deets, you gotta stop poking the bear. I've already mentioned what's going on with Burn the Subs earlier and why we're not working on it. But every single time you sub, you comment. I guess it's the privilege you get for the money you spend. I appreciate it very much. Deets, you're all over the other boards. And you will inevitably get your name on the new one when we finish it. We will work on it soon. I've wanted to give it a little bit of time to marinate because I want to make sure that that epoxy that we did isn't going to soak everything in water. Because like stuff, you know, the epoxy will solidify around the plastic, and if they move and age differently, there's potential for a leak to be there. I want to make sure that there's not. But I say that, you've subbed and run, and so you're going to do the same thing next month. which I appreciate you subbing very, very much. There's a conflict of interest there. All right, let's put this thing up on the screen. So we're going to add an image slideshow. Where is, which one is it? Come on, browser, output, color source. Well, actually, we could just put MS Paint up on the screen. Wait a minute. Which one would that be? That would be a window capture. MS Paint. MS Paint. And there it is. Okay, so we can just do that. We're going to mark off where we are with this thing as we go. Let me make that a lot smaller. I'll just zoom in on it for you guys. So this is the diode ladder circuit. It requires a lot of diodes. Oops. This one. Let's just make sure our file's the right one. We don't need the desktop one anymore. So now you go back to my project. I need to go to stream. You guys can't see this. And then that's going to go in synth, and it's going to go in diode. Where is that one? Programs, crimes, diode ladder. There we go. Okay, so save that one. Place it. Okay, cool. I'm back. Okay, cool. There. Okay, so that's our working document. So should we start? I mean, starting with power is not necessarily the best way to go, but that power plug is pretty big. So we do need to give it its real estate. Right now, what we have are the ins and outs. And the reason that I chose to reuse the VCO, whatchamacallit, the VCO thingy-madoodle, the VCO circuit board is because it's got 3 plugs on it. So we have a audio in, audio out, and then we have a filter control voltage. That's how we're going to do it. So audio out is on the left. We got to make sure that we get that right. Let's get the larger things in there first, which would probably be the power supply and then the stuff that makes the power safe. I guess I could put the scope up here too. Do I already have one? I think the scope is somewhere here. Nope, that would be that one. Here it is. Oh, it's not functioning right now. Wait a minute. Properties. Oh, sorry, that's the oscilloscope. Never mind. All right, well, we'll go to the different view. We can look back at the schematic later. Okay, so whoop whoop. This is summon the police. Whoop whoop. All right, so power plug, standard synthesizer, 10-pin power plug. The stripe is minus. The other side is plus, and in the middle, the ground. So that's this guy right here. Kind of big. I insist on using, instead of just a pin header, I insist on using a shrouded IDC plug header, square header. What's up, Clipper? Because my friends are idiots, and I'm almost constantly repairing synthesizers that they've blown up. They blow them up. They plug them in the wrong way. To take advantage of the size, the width of this thing, I don't think I should be putting this thing directly in. We're not going to have a 3-volt regulator on it. I guess I could save room if I go all the way up like this. So if I go like this, and I put this up in the corner the way that I have, nobody puts power in the corner. I'm putting the power all the way up in the corner like this, towards the edge, which is, I guess that's acceptable. And this way I have a little bit of room to get power out of it, but also I overhang the largest part of the plug onto the superfluous part of the board. I guess. I don't know. Any other thoughts? I mean, the other way that I could do it is here. But if I do it symmetrically, now I'm covering up a bunch of holes, even if I'm up on the edge. I feel like this is way less efficient. And if I overhang it like this, it's going to interfere with other boards in the synthesizer. You shouldn't go over your PCB edge with these things. So I think the best way to do it is to use this oddly large piece up here and just throw it in like this. Now, where does that put power? Where does that put ground? It's whatever the opposite of this thing is. So actually the stripe is down here. That puts negative down here and positive all the way up here. Maybe I want to flip that, and it could just go over the area that's really dumb. I could just paste over the area that has all the stuff in it. No, we got to put a lot of diodes on this thing, so I'm going to put that like that, and then that gives us all kinds of real estate. We've got a big section here for an op amp. Since the op amp is solely responsible for the ins and the outs, we'll put the op amp right here, and then our diode ladder can hopefully fit somewhere in this space. What is that? There's a lump. Oh, there's a little lump of solder right there. What up, Keeper of Maps? How you been? Good to see you people. Good to see all you folks out there. A lot of familiar names. Yeah, so the surgery was not on me, but on the family member went perfectly fine. It was like a nothing. He was already walking around and being a nuisance the day after. Says he felt like he got hit by a truck, but that truck's name was probably Da Vinci, the Da Vinci Resolve. I mean, the Da Vinci surgery robot at UPenn. I think that's Da Vinci. I don't know. There may be a couple. Just cleaning up, making sure these are flat so that I can put something over them. All right. Crazy at work, crazy weather outside. The rain has been obnoxious. I haven't seen the sun in a month. All right, so we're going to put that there, and the way that I'm going to do it is, well, you know what? I have the plug out, so I'm going to plug in a plug to this, and that will sink out the heat and make sure that I don't distort the pins when I'm soldering. So what I'll do is plug this in. Obviously, this is plugged into a power supply right now, but the power supply is off. It's fully off, and I've checked. But now what I can do is hold it back here where I'm not going to burn myself and solder these pins, and I'll get it anchored, and then I can solder the rest. Let's get solder over here. I have to switch tips soon, but for right now, I'll just keep the big guy on. Oh, that's right. You guys you're far north enough to get snow and stuff. We could amount to 20 plus centimeters of snow in the middle of April. Well, the beginning of April. That is madness. Surely everything is fine with the environment. Consume more. Use those hydrocarbons. Everything will be great. There's nothing fundamentally troubling about this at all. That's barely any solder, but I think it actually worked. I just got to be careful. I'll anchor the other side where I have more control. 14 plus Celsius on Saturday. Yeah, that's... What the hell? Here's a bunch of snow. Now it's gone. Haha. We got so much rain, though. We got, like, multiple inches. We basically got all of April's rain amounts in 3 days. That made our quota for the month. Yeah, exactly. Is it a cafe or is it is his house? The dog's house. I assume his, I guess, because it's not, all the cartoon gender coding isn't in place for female. I don't know what the dog is. I shouldn't make assumptions, but the burning dog meme. Dog in burning house meme. Dutch cartoonist. Okay, let's, yeah, I think it's his house. I don't know. I've read the original, I just haven't read it recently. Little bit of ASMR, visual ASMR soldering stream. Yeah, I know, that's not the part of the cartoon that matters. It does when I speak about it, though. All right, that's flat. It's flat down on the circuit board. I don't want to have a crooked power plug because that reflects badly on me. It makes me seem like I'm sloppy. I mean, it's not the only thing that would make me seem sloppy, but it is a thing that would make me seem like I'm sloppy. Boop. Okay. Clean the iron off. You know what? I'm going to switch off the big tip because it's hard to maneuver it into these things without it getting everywhere. The big tip is mostly good at reworking stuff. Not really good at working stuff. You guys like the way I work it. No diggity. Got it in there. Get all this stuff in here. Put this over here. All right. This tip is sort of a blunted pen tip, and it is utterly perfect for working in this size of electronics. The reasonable sized surface mount and through-hole mixture for prototyping. And I've learned how to work with it really, really well. And then, 5 years ago, it all became completely obsolete because circuit boards are $5. $5. Utterly ruining the entire process that I'd spent so much time to cultivate and learn and master. Solder reworking, of course, is still very functional because people make mistakes and stuff blows up, but it's this whole perforated prototyping thing that I'm doing right now is not entirely necessary, although this is still more reworkable than a printed circuit board. So, barely, but the trouble of putting something like this together versus a printed circuit board is man, there's a vast difference in between them. Wait, a vast difference. What did I say? Is that a body part? All right. Bonk. Bonk. We got power. Negative is here. Positive is here. Double check. 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 It's the opposite of what this one says. Yes. Okay, so wait. That means stripe is here. I have that marked negative. Oh no, that's a pin 1 marking. Okay, I thought that was a minus sign. So yeah, unfortunately, yeah, this is you flip the power thing around and then you flip the diodes around and this works. I put it in backwards. I thought the wrong one was the wrong one. So I'm gonna actually double check that with something that knows what they're talking about. Let's actually double check that with something that's legitimate. So we'll go here and we'll look up Modular Synth Power Pin. So we get this picture, which has been sort of the master picture for everything. So if the gap is here, positive is at the top. That's how we know. Yeah, exactly. I just don't want to get it wrong again. So we need some diodes. I need some diodes in order to plug in power. What did I buy for diodes? I had some solution for diodes. I think I bought just like a ton of diodes. And then we'll need a couple capacitors just to make sure that the power coming in is nice. So let us find what are they? The Schottky diodes. So most diodes have a 0.7 volt or 1.4. They have a pretty standard voltage drop. Are you ovulating yet, son? Says Gonad as he busts the door down. This thing does work. I need to tune it, and I need to build an LED engine, but I didn't want to have a software stream. So I need more filters. Hajiwo has some amazing filters. You guys should all check out the YouTuber Hajiwo. He's much better than Flatulent Gonad. Also check out Flatulent Gonad. He does cool stuff too. He streams cool stuff. Yeah, but anyway, we have a diode ladder circuit from Hajiwo, and that diode ladder circuit looks like it's relatively easy to build. It's a little bit complicated, but it's right up our alley, and it doesn't use anything digital. So we're building that, and I'm going to cross out all the stuff that I build on the MS Paint drawing. Trust but verify, except when it's chat. Yeah, exactly. Yeah, I know the mistake. It's just, it's that whole thing that when you put, like if you're working with through-hole, this is why I hate through-hole. When you're working with through-hole, you put all your stuff through the circuit board and then you flip it over and everything is then mirrored. And you're like, wait, what pin is that? What pin is that? They used to sell these little things that you could put over the pins when you were like wire wrapping circuits. You could put this little card over the pins and it would label what number the pins were for like an IC, because it's such a common problem. That's why I love surface mount, because you're looking down at the board and all your pins are all your pins. You don't have to keep second guessing yourself on flipping things. I used to flip stuff in Paint and look at it backwards on the Paint thing. And then you're like, wait, did I flip that so that it would be easier for me to see it? And then you'd look through a data sheet, and sometimes the data sheet would be like, oh, this is what here's the pinout looking from the other side of the board. And you're like, what? Huh? Wait, what? It's so confusing. It's so constantly confusing. We're looking for the Schottky diodes. Schottky diodes have a very low voltage dropout. That's why you use them as a barrier, Schottky barrier diode, that will keep you from blowing up your synthesizer if the gorilla with a troglodyte brain plugs in your cord backwards. How could that happen, bother? It's an IDC cable. It is a very clear keyway. Listen, I feel you, but it happens. Oh. Joe said the exact thing that how did that get into my brain? And then, see, this is why I don't watch other creators, like, more often than not. There's some creators that I will watch, but some of them I cannot watch because their vernacular will make it right into my brain, and then I just repeat what they say without thinking. It's crazy. Just JoJo's fine. No, it's not. I have to say JoJo. Schottky diodes. Boom. There's 4 of them in here. What the hell? Oh, here's a different Schottky diode. There's a billion. Okay, cool. We'll use those. Close this thing before I knock it over. Now, these are tiny. These are the size that Mutable Instruments used, because I built a couple mutable instrument circuit boards in my day. They are designed to maximize the amount of space on the board, which is not good for us because, boy, if you ever want to feel inadequate, build a Mutable Instruments circuit board. Now, there are some remixes of those circuit boards out there. I didn't look for them because I didn't know they existed, but some people have made Mutable Instruments remixes that actually enlarge all of the parts so that you don't make all the mistakes that I made. Because who was that I was messaging a YouTuber who had these DIY sort of the finishing touches on the Mutable Instruments builds, and they showed how to program them and stuff like that. And I messaged the person, like, in the throes of all of the mistakes on the board, like, why isn't this working? What do I need to do? And he had a couple suggestions, and he was really nice, but it turns out I should not have messaged anybody because all the mistakes were in the soldering. I had to go through, and I had to learn what the resting voltages on the pins were, and this could have been something that I programmed. I could have programmed a serial print if I had understood STM32 more. But what I should have done is had serial print out what all the ins and outs are. That should be the first step in making, like, a heavily digital modular synthesizer module. What you should do is have a test print in the microcontroller tell you what all of the ins and outs are that it's seeing, so that you can make sure that your hardware works perfectly fine. And that's what we did with this. That's why this is a little bit less irritating to put together. There's still a couple things that I need to, like, tweak and tune on this thing. What is that LED, like, going downwards? It's like, maybe I've got the wrong position on the model. Yeah, it's like tilted downward. Well, that could also just be because it got bumped while we were working on the circuit. That's probably the case. All right, anyway. Bonk. Okay, so let's get the diodes in here first. We're going to start with the power supply. That's because that's going to take up a little bit of space. And I will build on the same side as the holes because that plastic is going to get in our way. We can just stick a diode here and here, and then we'll just put a little bridge over to the other pin. And that'll be our power and -12. The 6 pins in the middle here, those are all ground. I even put moisturizer on, and yet I'm still dry as hell. And it's been raining for like 4 days. Which one is positive? Which one is stripe? I'm going to go ahead and mark stripe with a marker, because I've already forgotten, which is bad. I don't think I have a functional brain, chat. So with the 10 pin facing this way, like that, the bottom, the part that is separate from everybody else, is stripe. So I'm going to get a marker. Use pink. Use pink. Hopefully there's some ink in this thing. I'm just going to mark this with a stripe down, and then put stripe here. I'll put a mark here too. just to make sure that whoever's looking at this thing sees multiple different markings on the pin that's going to have stripe on it, and not try to wrench a cable into the thing backwards, which has happened. Oh yeah, one of these cables is actually a liar. One of these power cables. I need to fix it. I need to reverse it because I built it wrong. Having your cables lie to you too is also another way that I've been gaslighting myself into building circuits wrong. What fun. What fun. How's everybody doing today? We just, in the north, you can tell which chatters are from the Northeast because they're like, holy shit, I saw the sun. Northeastern United States, I should say. Gunad's just from England. He just never sees the sun anyway. Let me see. So what is the direction of these things? Well, the problem with these markings is that these pens will wear away pretty easily. Like if I brush my finger on that, it'll start vanishing. I probably should pull this schematic up on the scene, on the microscope scene too. I guess I could do that real quick. Hold on. You were waiting for that one since the intro, weren't you? That is a long con right there for the has the stream started yet comment. You were waiting for that one. You typed that in and you waited like how long? Half an hour? Let's window capture, and this would be Pont. And there it is. And let's make that small. Where can this go? I want to show all the stuff. I guess we'll keep it like right here, and I can work over here. My workspace is getting smaller and smaller. There's too much stuff on the screen. This is like a gonad stream. All right, so Schottky barrier diode, 1N451 something or other. Oh, they're not represented in this one. Okay, so let's dual screen. Yeah, you have to tune into two different streams in order to see what we're doing. Show me your diodes. Well, I mean, okay, so we know that from anode to cathode, the arrow points in the direction of what we assume, well, Ben Franklin's current. That's an idea. You dual stream. I don't have enough viewers for that. Modular synth protection diode. I could look at a different schematic, but it would take more time than just to Google image it. That doesn't really help. There we go. That's what we want. We don't need the coils in there. That's kind of a really advanced way to do it. But so basically coming out of this doesn't, negative, coming out of the negative, we want the cathode pointing towards the power plug because the flow of current is from ground to negative and from positive to ground. And again, that's just the directions here, or from positive to negative. Either way, we want to allow that to go through. And if you plug the thing in upside down, we want it to block. So what I'll do is plus 12 volts in, we will draw it, and we will do one of these. Oh, I drew that really badly. That's okay. That. I could use the line tool to draw it, but eh. Oh, did it wrong already. That is the worst arrow I think I've ever created. There we go. Towards ground. Okay, so that's the direction of the diodes that we're adding in. Oh my God, motion detected at the front door. It's a nice day. Everybody is out. Things are going nuts. I could output each monitor to its own channel. That would be really cool and unique. When are we gonna like collaborate and do something really weird? Probably when we get viewers. Probably if we had more than viewer, we could do some pretty innovative stuff. That's like something like Sushi Dragon should do. So you can see the line on the Schottky diode that's going to tell us the direction of the flat bar. The arrow points into the bar. You can think of the bar as the valve and the arrow as the direction of flow. Yeah, I've been bad enough about not collaborating with BeamNG Drive. Rob Oz was doing a little BeamNG, and I was like, man, because he downloaded the whether it's not Perjave, whatever. The My Summer Car map he downloaded and was pooping around with, and he was building a car yesterday. I think he's going to do some beam today. So the arrow is pointing into minus. That means this one goes in this direction. I'm soldering without something plugged into the connector. I don't like doing that. Because the longer you expose heat, the more you soften up that plastic. And if that plastic softens up too much, you're in for it. It'll bend the pin, and then you got to either bend the pin back, or your connector doesn't fit properly, discover, or all kinds of stuff. This is not flowing onto the pin just because there's something there. Just make sure. You're on a short list of people that I need to collaborate with. It's a very short list, but it's there. Uda Oo is another one that has said we should collaborate in my own stream. I think maybe I had a slightly impressive number of viewers at that point, but I think I'm a little cerebral for the type of stuff that he does. Maybe we could come up with something, though. Wreckfest 2. Yeah, that's Rabaz actually did a bit of Wreckfest yesterday. I was watching that. He's bringing out all the old hits. Wreckfest is a very, very, very fun arcade game with cars, and it's sort of a car people game, but not strictly. Because, like, the stuff you do with the cars is fun. You crash them together. So hee hee ha ha. I don't know too much about cars. I want to, like, crash them all into each other. That's acceptable, just as hee hee ha ha. I know a lot about cars. I know exactly what kind of tuning I want on this one. Is also there for fun. It is a very fun game. I like that game a lot. I'm going to plug in a power plug, and we're going to do all of the soldering for this thing. We're going to get that out of the way, and then we'll get to the rest of the circuit. And I'm going to start crossing stuff out on this schematic. So let's get that all done, and then we'll get the capacitors in here and do those as well. The capacitors I'm putting after the diodes because I don't want the capacitors to also explode. What we will be using, and I need to actually get it out. I knew I'd be doing this. I need to get this out from over here. Is wire wrap wire. Oh my God. I had more of that supermarket hoagie that I had yesterday, and it turns out, I don't know what they did. I think maybe it's the Italian dressing, but it is causing me to have some of the worst heartburn that I think I've ever had. And I don't know, I'm like a moth to a lamp. I'm like, ooh, hoagie. And I just go ahead and ate more of it again, and it's causing me exactly the same heartburn. So I will be pausing to take big drinks of water to try to actually Hulk hoagie. Salami burp. That's my secret. I'm always salami burping. This is wire wrap wire. It's 30 gauge. Wire gauges go in reverse, so the larger the gauge, the smaller the wire. This is 30 AWG, American wire gauge, because we invented everything. What's up, Tim? 1980 62 19862. America invented everything. That's why we have 0.1 inch spaced boards. That's why we have the internet. That's why we have 30 gauge wire. This 30 gauge wire is very small indeed. This stuff is not coated. That's why I use most of it. I will use this in order to, it solders very easily. It's meant for wire wrapping. Wire wrapping is when you have a square post, a square edged post, and you wrap a wire around it very tightly. And when you coil that wire tightly, it will squeeze on that square post. The corners of the squares will deform slightly and bend, and what that does is it cold welds the metal to the metal, and it makes a very good circuit indeed. It's actually second to just soldering it. In Vietnam, they sent these kids out with radios that were more densely packed circuitry than you could get on a PCB, because the wire wrapping post could have multiple different connections from multiple different areas, and it was field serviceable. So it was actually quite a big advantage to the printed circuit board. Nowadays, you don't see so much wire wrapping because it's a kind of a big hassle, and we have things like surface mount, and we have things like $5 circuit boards. But the wire that you use in wire wrapping is solid, and so the solid core wire works really well with the perforated prototyping board in order to lay down all of your circuits. Time zones, hockey, basketball. Yeah, America invented the imperial measurement system. Believe it or not. We also labeled the flow of electrons backwards in circuits. And there's a very good reason behind that, is why we labeled them backwards. I need to push down on the wire to get it to solder. Actually, is that floating above everything? I would like to float both of these pins at the same time. That's sort of a big soldering iron job. Damn it. This is always such a, this is what usually makes me angry, and then I go and I just make a printed circuit board for the whole thing. We're going to resist making a printed circuit board for this. That's true. We have our own Imperials. And that's why we made Star Wars. Hi, it's me, oh bother. Would you like to solder, like, at all? I guess the iron's on, I'm just not getting good heat transfer. That's where flux comes in. I would maybe add a little bit of solder to the joint. What I want to do is I really want to sink that wire in because I don't want it to short against the ground. That would be sort of annoying to do. And to make sure that solder gets all the way around this wire, because it tins easily. It's fighting me for some reason. I guess I'm heating up the cable, as you can see. I wish I had more resolution on this camera. Fluxed capacitors. No! Those are diodes. Those are diodes, and those are flow control Schottky diodes, and those are designed to keep my friends from blowing up the synthesizer when they drunkenly plug in these plugs backwards. It's sort of the last what do I want to call it? I wanted to equate it to like the immune system, but it's the last defense that it's the blood-brain barrier of the synthesizer. It's all it can do to keep from exploding. Making things drunk-proof is impossible. Well, that's true. Something, better idiot. I know them all. I know them all, and I've heard them all, and I've used them all, and I've experienced all of them too. And I've been the idiot a couple times, on a couple interesting occasions. What I really should do is fancily wrap this thing around all these posts. I'll just do this. We'll do a big S out of this thing. Do an S. Pull! I guess that's not going to straighten out because there's solder on this part of it. That's actually what Crimes and Ornamentation did. Because there are components that are diode bridges, and they're for rectifying signals. So what Crimes and Ornamentation did is they put down a header that doesn't have a keyway on it. It's not boxed, it doesn't have a keyway, and you can plug it in either direction. The reason that I would never do that is because without a shroud on it, again, my friends would end up plugging it in one pin off, and that could potentially damage the circuit in a big way. Which it has, and it has been done, and it has been done by my friends, because the M303, the 303 replicating modular synthesizer module, does not have anything around that plug. It doesn't have a box around the plug for the insulation display connector. And so you can plug it in, and you're supposed to actually plug it in with an offset. He didn't know that. How would you know that? How would you even know that? It's so unintuitive, it's almost like they designed it to break synthesizers. I don't think the module is sold anymore. I think it's discontinued, but they have some weird, oh my God, that was painful. That was a lot of acid that just came up. Woof. Fuck you, Hoagie. Jesus Christ. I shouldn't have done that. I knew this would happen. I knew exactly this would happen. I said, you know what? If I have more of this hoagie, this delicious, delicious hoagie, I'm going to end up having the worst acid reflux ever during my streams. Supermarket hoagie. And I guess it had a lot of Italian dressing on it, and that oil must be causing me to have awful, terrible heartburn. But and I'm talking a lot, so there's a lot of exchange of gases out of the front of my face. But yeah, anyway, the blimmies, blimies, with a prime for 5 months. What's your coffee count limit before soldering? 1 here. I've had 2. I don't generally have shaking issues. Most of the shaking issues can be alleviated by putting your hands down on the work surface, which is why I have this camera going. You can see that what I'm doing is like fully cradling this thing. I'm holding on to the vise and I'm leaning my fingers against it in order to stabilize all of my movement. And I'll try to stabilize it all the way up to the pen. The pen I am, of course, holding like a pen, but you know, the shakiness, a lot of people complain about shaking. Like if I just hold my arm out, I'll shake a little bit. And actually, I've been shaking more than normal lately, so I probably need to start working out again. The more muscle you have, the more steadiness you have. It's the same thing with shooting guns. You need big muscles to hold everything steady. But unlike actually similar to shooting guns, you could lean them against stuff. And so leaning against things that have solid footing is not just the technique, it's pretty much the entire thing about how I am soldering stuff so easily. Why is this not soldering? Speaking of. Go. What? Oh, this is I'm holding the solder. I keep adding solder to it thinking it's wire. Oh God. The other side of the board probably has a ton of excess solder on it now. I keep trying to solder it in. It wasn't even, oh boy. Brain, are you okay? Teams call. All right, have fun, keeper of maps. Good luck. Yeah, blimmies or blimies, I don't know which one to say. Thank you for subbing. Really appreciate those subs. You guys rolling in some of those subs. We didn't stream on Tuesday because I was getting a family member home from the hospital. Successful surgery. Probably was the Da Vinci robot, which I call the Da Vinci robot. Oh, I think I just lost the knife tip on the table. It caught, and then it blunted my... Oh no, it's still there. Okay. Those are the worst. When you break the tip off of one of these things, and it's like sticking out of something, it can catch you. I got. All right, so after the diodes come capacitors, and so we've got a little bit of room on this board for a couple caps. The surface mount capacitors are actually going to sit below the connector, so I probably should use those. We've got kind of this wasteland sitting right next to the connector, but the diodes go to here. And I can actually use, well, I got to be careful about that. If I use the through-hole caps in a perforated prototyping board, because surface mount caps in a perforated prototyping board, if I use them and I take the bottom off, they're not insulated against the board. So I need to throw some Kapton tape down. Let's find the caps that we want to use. Now, Hajiwo calls for 4.7 UF. Anything kind of in that range would be just fine. We're just trying to filter out little transients that are on the lines. Just make it clean. So we're dealing with a plus minus 12 volt power supply. That means we can have up to 24 volts in potential across these capacitors. So 50 volts is a comfortable place to be. Those are 10 UF. These are 4.7 and they're 50 volts. So we might as well just use what's called for in the schematic. So I'll grab a pair of these things. These are good parts to have around, these, even the surface mount ones. The only problem is I need to alter my part in Fusion 360 because the part in Fusion 360 gives you exactly enough pad to solder, which is bad because whoever designed these things is evil and they only leave a little tiny bit of wing to work with on them. They're so annoying. All right, we're done with the power connector, so we can unplug that and get that cable out of the way. I just happen to have this sitting here, so I plugged it in to mitigate heat. So yeah, now we can just throw a couple caps down here. And these are good places to throw down caps because there's not a whole lot that will interfere with, like if I brush this with my hand, I'm not going to hit the cap. Yeah, I guess, but like getting the whole, and that's what I did, is I got the whole hot air station out but it's still annoying. So the stripe is negative, so what we're going to want is for this to be... Actually, I'm going to use a larger cap. I'm going to use something larger than the 4.7s. I can get away with it here, since we have a ton of room. That just means that it'll take a little longer. It'll take a couple more milliseconds to come up to power, but it'll have much better... That's 35 volt. It's still over... It's still 20, you know, 24 is still okay with 35 volt. Might heat up a little bit if it does get totally shorted out. But that gets us a little bit below... Yeah, that'll be good. Those are just below the... These are 47 off. These aren't 4.7. So these will filter out lower frequencies than the 4.7s. And since my power supply is really good, because I'm an EE and it's a point of pride to make the power supply really good in your synthesizer. Since all that is true, there aren't really any low frequency transients on my power line. Now, what I'm doing right now is I'm just sizing it out. It looks like these would barely fit like this. And if I do put them in like that, where's the other one? There it is. If I do put them in like that, I'm going to have to drill out the in-between holes. So that one goes there, and then this one goes... damn it. So I could do that, I could drill out the center holes, and then I'd have 3 attachment points. Boom, boom, and then boom. And I can solder those practically from the other side of the circuit board. I'm going to have to handle the PCB in order to do that. But let me just get the drill, and I'll just drill out those two. For the drill, I'm using something that Mahalo sent in, which is not the little gun drills. It's the big boy DeWalt screwdriver. Although this thing does work for that, and I think we used it last time. It takes double A's, and it's a little... Hold on, I got to rack the slide. Okay, there we go. I can't believe some... excuse me. Some employee of Tamiya sat down and went, all right, so I want to make a little plastic drill so that people can put together a cute little model, and they can have a drill that is capable of, you know, working on their plastic models wherever we might require somebody to use a drill. And they sat down, they went, all right, inspiration, I need a hand tool. And I went, gun! I'm going to make it look like a gun! Very strange. All right, so I've got these shucks that I bought specifically for this. What size hole is this? Not that drill bit size, a different drill bit. Where did the other drill bit go? Here it is. This might be the size. I think this one is specifically cut for plastic. So it does an okay job on the FR4. I don't think that's the size either. I may have gotten a different drill bit. No, that fits. It's a very tight interference fit. That's the one that came with the little drills. Walther SMD. I have the other one that Mahalo sent in. There's 2 of those types of Tamiya drills. They're okay. Obviously, this thing is a lot more expensive, and this is for doing screws. This thing is great when you have the modular synthesizer and you have to take out a whole bunch of hex bolts. You can just pop them out with something like this. I don't really subscribe to this auto screwdriver thing. I think you want to build up those beautiful wrist muscles, right? You want those wrist muscles, and you want those injuries later on in life. You know, I appreciate using your hands to build stuff. I don't know about using machines, but this thing makes a nice little time saver where it comes in handy. I've turned around my opinions on these things. I'm using this one as a drill. So it's this one and the one next to it. And what I'm doing is I'm drilling out this hole because I don't want it to connect. I don't want it to short out my capacitor. FR4 could be kind of difficult, can it? Did that drill it out enough? I don't think so. I know, adding more holes to this design is not exactly ideal. I don't want any of that metal left over, so I got to drill out the whole thing. This is going to get in the way. Of course, you have to tilt this to actually start it drilling. Whoa, that was weird. I guess I'll have to just hold it and drill it. Also, this thing isn't making any progress. I need a different drill bit. To be fair, that thing is not drilling properly. It's cut for plastic. I guess FR4 doesn't quite count, huh? These are cut slightly differently, I think. I'm just using this one because it's comically long. It puts me all the way over here. Okay, that was weird. That wasn't the one that I was drilling. Oh, there's already a hole there. That's what it is. Weird. Okay, that also happened comically quickly. What the hell? They both just vanished. All right, guess that'll do. I'll just put this back in the drawer like this. Actually, no, I don't think it fits. It needs to be shorter. There we go. I think blasted a hole in the circuit board before I even knew what was going on. Whereas the other one, the one that was cut for plastic, was just sort of spinning its wheels. Okay, so we're putting, I mean, actually putting the caps on this side of the board would also be acceptable because this is protected. So I guess I should put the caps, well, but if I put the caps here, I can't really run the wire. So I'm going to put them over here. FR4 probably does a number on the bits. Must be a brand new bit. Do I need to get the squirt bottle? Squirt my drill bit a little bit, cool it off. I'll have a little mister system. No, that bit came with the Tamiya drill. That was part of the Tamiya drill, and I guess it's pretty dull. Well, no, it's cut for cutting plastic. It's made for cutting plastic. That's why it's so inept at FR4. All right, so we need the magnification for this to make sure that everything is in alignment. And I need to solder one of the legs to this. We're reusing this board. That's why everything looks particularly sloppy. Let me get the big solder down here. The big solder. I've got two sizes of solder. This stuff is better for the through-hole things, and you know, when you really need to lay down a bunch of solder quickly. So with negative facing in the one direction. Oh my God, my dog is doing nothing but barking today. Nobody's doing anything to stop her from it. I guess she's having a good time, as long as she's having fun. She should be taking a nap, though, because her leg is still bothering her pretty badly. It's not so much a thing when she has to run. Like, when she wants to run, she will just run. But when she's been sitting down for a while, she kind of struggles to get back up, and she's kind of hobbles around a little bit. So we're going to need an x-ray to see what the hell's going on with her. It is an ACL thing. It's a tendon thing. It's not going to heal on its own. We might need to get surgery. But I want the doctor to get a good look at it first. I can't believe she seriously injured herself. She's so young. Got her whole life before her. Same doggo, same. Yeah, exactly. She's like an old lady getting up. Oh, I got to stretch my bones. Is that going to fit? Yeah, that'll fit. Surely that'll fit. Surely that won't not fit. And, of course, the family members see her hobbling and go, oh, my goodness, she's hobbling all over the place. It's like, look, she might just have a habit of doing it. She doesn't show any signs of pain. I know she wouldn't... she might have just gotten into a habit of walking like that. So... we need the doctor to take a look and make sure she's not just going through the motions. Oh, did I mess up? Did I already mess up on this board? Of all the things. Of all the things. All right, I'm going to use smaller capacitors then. Let's get this one up. We'll put it back in the cap bin. Smaller caps. We're getting closer to 4.7. We won't use the 47s. Use one size smaller, which are these. Actually, these are how many volts? 35. These are the ones we used, though. These don't fit. These are the ones we used. These are 16 volts. Hell nah. These are 50 volts. Those will do just fine. These capacitors don't matter so much. What they are is basically just a little bit of energy storage on the front end of your power supply. They will get charged up by the power supply. They're not there for decoupling. They're there for big transients that might affect your circuit, that might affect your audio circuit in particular. Oh, I see. Was I off by a pin? I was. So I want them actually to be like this. So here they're going to be pretty much on top of one another. I was off by a pin with the big guys. Okay, well that's easy enough. First off, I gotta clean up my mess with the solder sucker. Oh, that's why my thumb hurts. I've been reaching up like this to get this plunger and then pulling it down like that. And I was wondering why this is like sore, probably because of my irresponsible use of the solder sucker plunger. I should reorient, or yeah, I should scoop my hand up a little bit so I get better leverage on it. I need one with like a cock. Don't cut that selectively, what I just said. All right, so let's do this one here. And I'll drop this down as far to the right as I can. You know, in spite of the nice sunny weather, we're actually supposed to get another storm later in the afternoon. I don't know if that's rolling in right now, if that's what I'm listening to. That could be the recycling guys, though. All right, so that's over to the right as far as I can get it. I can probably get it a little further, but I don't want to push my luck. Selective hearing in full effect, yes. That's how it works around here. I guess I got my one comment from a YouTuber today. YouTube comments are still up on the screen. You guys can see them as they roll in. I've been doing my best to get this YouTube thing spooled up. Please just get warm. I like the cold because I'm a fat ass. I'm well insulated. Also, I have fucking breathing problems, apparently. So the cold air is more dense. We have chat now. You guys have always had chat. I've always commented on it. I don't know how many people are rolling in from all the VOD uploads. I'm so burnt out with VODs right now, but I'm still doing them. I'm scheduled up until next week with the VODs. Oh, did it just not load on? Ah, that's trouble. Usually YouTube's the one that's rock solid with that sort of thing. I don't know how I'm going to solder the leg of this thing. I tried to move this one over and I couldn't move it at all. But this is like right on top of it. I need just a little bit of wiggle room. In the past, I've taken these apart and used the leads coming down off of them. But if the can hits anything, it'll blow up. What the hell? I can't even move it. It's like solidified on there. There it is. So there's a little bit like, because you can barely get to the hole to get the solder to go molten. Fuck. Come on. Just a little bit. Careful. All right, I think that's as far as I can manage to put it over to the side, which is literally 50% onto that hole. Just like not 50 and raining. Yeah, that was a little rough. Today it's crisp, very crisp out. And I think we've got a couple days of crispness, but it goes up a little later on because our weather patterns are so incredibly normal and predictable for this time of year due to, what is it? The jet stream being all fucked up from global warming. Thanks, boomers. Appreciate you. Working on electronics is one of those things where you're doing everything terrible for the environment, except not on a giant industrial scale when you're DIYing. Even though you sit there and you have to deal with the commentary and the blame of what larger factory sort of operations have done to the environment on a large, grandiose scale. they have somehow swung the PR to the little guy leaving their faucet on while brushing their teeth. So a lot of the things that we do when we're soldering together, you're using lead, you're using fiberglass, you're throwing everything away in the garbage, you're throwing that car battery at a dolphin. Well, I have news for you, Mr. Environmentalist T-shirt. I'm holding a car battery and you're not. So watch your mouth. No, it's just one of those things where like it is pretty wasteful and it is pretty bad for the environment, but like me doing it on this scale isn't. Me ordering circuit boards is probably not all that great for the environment, to be honest. It's not like I'm Taylor Swift taking a private jet across the office. It was like a 2-hour drive. Is this going to solder down there? I don't know if it is. I'm going to hit that with Tachyflux. Just a little tube of Tachyflux, a little bop, a little beep boop of Tachyflux. My not driving everywhere because of the pandemic and because I work from home now is probably the biggest thing that I've done to help our environment. Yeah. Yeah, not as bad as pretty much all we can achieve. I guess I'm going to have to hit it with solder from above because it doesn't appear to be flowing onto the pins. The pins are probably floating a little bit. Even though I thought that the dollop of solder, oh, it looks like it did actually flow over. Let's just hit what I can here. It didn't really flow back across the leads though. That might have. Ah! Yeah, like you see, there's no solder on this part of the lead over here. It's only soldered like the tips of the leads. Weird. Well, anyway, I guess that's effective enough. So that is our bridge of capacitors, and positive 12 is over here, going to the positive lead. Ground is here, so positive to negative on that one. That's going to be 12 volts between those two leads, and then another negative 12, or sorry, ground 0 volts to negative 12 across these. So they go in this orientation. And I will use wires to get to them. And then from there, they go to whatever I'm powering in the circuit. There's a couple different elements. So many reels of wires here. Here's one. Here's one of them. We'll just go from here over to there. Since these still have the plastic insulating piece on them, I don't have to worry about them shorting out. Otherwise, I would have to run either Kapton tape under them or, I don't know, find through-hole capacitors. Through-hole capacitors have shrink wrap on them. So those don't, make contact in the same way. But these are surface mount capacitors. What's up, Wayne Johnson? These are surface mount capacitors, and they don't necessarily, they don't shroud the can. I've blown up a couple things by actually not respecting that. I've had a power supply module that I put on pin headers, and it was contacting a board like this, and the board like this shorted out the leads of the capacitor. And it blew up my expensive, it was like a $20 power supply chip. $20 just up in smoke, which happens in this hobby. Jobby. Blobby. That works. That works. What just fell over? Oh, it was a speaker. I got speakers coming out of my ears. I guess I'll cut this one here. I don't really like cutting them here is annoying because from here I'm probably going to be attaching another wire to it to get it to where it needs to go. But I don't know what the rest of my circuit's going to look like yet, so I'm just kind of like making it up as I go. But I'm trying to, once we get the power supply down, we'll be able to move into the larger elements of the circuit. And I think probably the op amp is the first thing that I'm going to put in. Thinking about it, I guess power is the thing that I would want to run a little bit less like as the crow flies. Because if I do run the power directly, if I put that op amp all the way at the bottom of this board and then run power directly over to it, I might be blocking tons of stuff. This is like not soldering. Why are you not soldering? This thing turn off? No, it's still on. My phone buzzed at me and I need to check to see whether that's either a motion alert at the front door, which I can ignore, or if it's my glucometer telling me that my blood glucose is falling or rising quickly. And if my glucose level is up, I will get more heartburn, which I really want to avoid. but my throat kind of feels like, my throat feels like I snored my ass off last night, which I probably did. Motion, glucose level's good. All right, we're good. I can actually show you guys. The effect of the hoagie on Oh Bother. Oh, hear my dog barking again. Oh, it's not on that one. I think this one has it. Boom. Oh my God, look at all the work that my pump did there. Whew. 0.3, 0.3, 0.3. This is supposed to mimic the way the pancreas administers insulin. And it actually saves a little bit of insulin because your body responds to it better. Supposedly, my body doesn't respond to shit. Inertia. Volume. Okay. Exercise. So I think the op amp's going to live right here. There's a lot of other structures that we have in here. We get transistors and stuff too. And the op amp is mostly responsible for processing the ins and outs. So here's our out. And here's our in. And we've done all of this. These are 10. That doesn't make much of a difference, but we're done this. So now we go, I guess, to the CV input. Frequency CV. That would be, well, there's a frequency CV and then there's the audio in. So this one is, so on the front, we have the 3 like this. This one is here. And then this one is here. So the op amp, and then of course this one is that third one. And so the op amp interfaces with these two. The CV, we could jump up and put it up top. It's going directly into the diode ladder. I don't know how spread out the diode ladder. I don't even know what that's going to look like on the circuit board, to be honest. Decent looking response, no overshoots, smooth. It's when you double the feedback loop that happens. That's what Disney invented with their robots. Robots. So those Disney, every now and then there's one of these Disney Tech Hub videos that comes out and they showcase some kind of technology that's supposed to save them time in animation. And it really does display how humanity is going to be taken over by the machines soon. Like, I think I'll do most of the circuit elements on this side of the board. So how am I going to put down this op amp? What we have is a TL072. And I think I've got one sitting up here that I can just grab. And it's a TL072 because we need 2 op amps, but only 2. TL072 is a workhorse op amp. It does pretty well in audio. It goes from rail to rail, positive to negative 12 volts. What do we have right here? This would be MCP 6002. This one is a 0 to 3 volt op amp, which is good because that one works well with microcontrollers. Microcontrollers that can only take 3 volts in. You put an op amp in there as a first stop. You can do a little math on it in order to get the voltages into the right place. And then this thing cannot access voltages that will blow up your microcontroller. So I'm going to put that up there. And then I'm going to get the other one of those little chips that was floating around. Where did it go? Where did it go? It's somewhere on this thing. I just threw it on here and then threw this thing up top. Let me bring it down and figure out what this piece is. I have hundreds of these things. I could go get one from a bin, but it's faster to just grab one that I know is already out. So there's this one. This one is a TL072. I need to look up the pinout of the TL072. Jesus Christ. I'm not into insulting my op amps, sir. TL072. Oh, I can put these caps away. Really? You're gonna... Really? Man, takes all kinds. Lame. Okay, so TL072 And then we're going to take a look at the data chart. Where is that? There it is. And that'll give me the pinout, among other things. I mean, there's all kinds of good information in here. I don't know what the gain on the TL072 is. I think Mortis Klein was saying it was like times 100 or something. TL072X, DDF, blah, blah, blah. We're looking for SOP, so not this one. Or no, SO8 is what we're looking for. That looks like the radiation hardened package. There's some weird packages for chips. Very, very weird. Is it all the way up here? Search is really not going to help us out with this. But we know that all the pinouts are in one particular location. TL072, here, let's look up the specific part number. C. Assuming it's they use the same nomenclature. TL071 A, B, H. Okay, all right. Well, TL072B is where I want to go. No! Oh, that doesn't help us out at all. Plus, that's the totally wrong package. We're looking for SO8, so let's just get down into the chips here. I think it's like way down here. TL072, blah, blah, blah. Those are the characteristics, the min and max. SOIC, or SO8. 8 pins, that starts up here. SOT23, SOIC, D, DDF, J, etc. I don't think that's right. Hold on a sec. SOIC and SO, SO8, SOIC, TL071. So that's, we want TL072. There's a lot of this stuff. You get better at it with exposure, but SOIC, SO, and TS. Okay, so this is the package that we have. So VCC plus, out minus plus, out minus plus VCC minus. All right, cool. So how are we putting this down on the board? Well, wherever we put it, I probably need space above and below for all the components. And I know this because I've put these down before on designs, and I've had them not have that room above and below. And the best way for us to put this down, I mean, we can put it in the middle right here, and I can put tape over the middle pins. It would be much more functional to me if this were the type of board that I like to use, which is this stuff. I need to order more of this stuff because I don't have a lot of these anymore. Where is it? Hold on, let me get it out and show it to you guys. It's so much easier to work with surface mount like this, is a piece of this perforated prototyping board. It's a little hard to find, and a chat member found it the last time I ordered it. This one is filthy, and I'm still holding on to it, but it's got square pads, and it has no vias. No vias, square pads. It's not plated through. So one side has the stuff. Now this could tend to become weak and drop stuff if you put a lot of heat on it, but because it's square, I can very easily orient things like pins for ICs and stuff like that. In the past, we've blocked off that center one, but I don't think that's really going to be that useful to us. If I block off the center one and I attach the ends, the outer ends aren't really, because these two are going to be the ones that are doing the work. You could move them over there, but that would be a little awkward. So I think what I need to do is just place this in the center of an area, and then I can run little wires to 1, 2, 3, and 4. Now there are breakout PCBs that you can buy for these things, but you know, that's fine. We don't need that. We don't need that. We don't need that. I'm just going to put down tape over these 4 holes right here, and then we will put some super glue down, and I'll plop this thing down with super glue. Actually, I think it needs to be, yeah, it needs to be like that. So we need to put tape over 6 holes. So I will do that, and then we'll figure out what the rest of the circuit looks like. Try to get that soldered in. So first things first, Captain tape. I store that up on the shelf here. Piece of it like this, and then I'll use the knife to cut it. This is just the thing that I commonly do with this kind of stuff. You know, one thing I don't do is fold over the end of the tape. It makes it so much easier to find. Can't believe I'm complicit in the spreading of terrible jokes through my own chat. I could be tried at the Hague for such things. All right, so now where do I want this thing to sit? My op amp is going to look like, well, they're going to look like kind of unique structures, both of them. This one is fairly common. So this is a this is an inverting amplifier. And so I'm going to need a 100 kilo ohm potentiometer. So that'll be a 3-pin plug, or, you know, maybe all of the wires I can attach to a certain part of the board where they come in and out. That'll be by the power connector. So I'll have another pin header all the way up here that'll have all of the connections to the back panel, probably on the other end of the board. Adelaide, Australia. Oh man, my cousin is also an Aussie, but I have to actually pull up a map because I'm really bad at remembering where he's from. I'm like having a conversation. Oh yeah, I totally know Australia. Yeah, very well. Oh yeah, don't even look over at the screen at what I'm doing right now. I know my geography. I don't think he's in Sydney. I think he might be in Brisbane. I think. Brisbane. I don't think he's in Perth. That would be ridiculous. See, I know all the places in Australia, just intuitively. Welcome to my electronics stream, where I do all kinds of zany shit. We're trying to build a circuit from a fella named Hajiwo. Hajiwo made this circuit, and it is a diode ladder. It's a diode ladder. It's a diode ladder filter, and it's a voltage controlled filter, a VCF. I'm hoping that one day I can make something even resemble. Okay, blood glucose level. I don't get out of my way. I'm hoping that one day I can make something resembling a synthesizer that these guys have, and have sounds that even just remotely sound like the really nice synthesizer tones that all of these YouTubers have. Because I watch these YouTubers and they're like, "Wow, build a $2 VCO," and the VCO is like, and I'm like, "Whoa, that's super cool!" And then I build the VCO, and it's just like, it's like, what the fuck is this? Like, I can't make cool sounding stuff. The filters help, though. God, it's Friday at 5 a.m. Yeah, that's the thing. Is like the only time my it's cousin, right? Yeah, the only time my cousin would drop in on chat is when he'd been out drinking all night. So I'd get weird comments from him. He's a cool guy, though. He's a pretty cool guy. Doesn't afraid of anything. Australia's a very big place. Yeah, it's an extremely big place. Aussies don't even know where everything is. Glad I found it, but need to head off to work. Jeez. Oh, so you're having a cup of coffee on a Friday. Like, hey, let's get our day going. That's crazy. Yeah, have fun at work. Have fun at work. We got an eclipse here coming Monday. It only just stopped raining. I don't know. Things are going okay. So I need to figure out where I'm putting this thing, and I think I'm probably going to stash it. Is it a little far over there? Maybe we put it like here. That gets us a little close to this stuff, but we can work around it, hopefully. Happy Big Friday. Actually jealous. What's so big about the Friday? Maybe move it forward a little bit. Put it right here. We'll do it forward. We'll do these 6 pins right here. I gotta remember that because I now have to go get the knife and not forget where the 6 pins were. So we're going right here. Didn't we just have Good Friday? What's Big Friday? Is that when all the religious people go and they work out and they get huge? Or is that Swole Friday? Whoa, hold up a sec. Let me handle the knife first, and then I'll read all these inane comments that you guys are leaving. Whoa there, bud. Whoa there, bud. Take it easy. Yeah, when I get to do like physical soldering on stream, I get a lot more viewers, and I want to do more stuff like this. It's unfortunate that this is a little slower then, like, if I were to design the circuit board in CAD, I could do that much faster if I had all my parts lined up. But physically building the circuit board brings people onto the stream. So I've been saying Big Friday every Friday because of the streamer avoiding the puzzle. Oh, he says it on every day. Today's the big day. Bubby with a Y. I call Willow Bubby. That's pretty much her name. We got Bubby. Where's my Bubby Dougie? I baby talk the dog way too much to be healthy. It's not healthy. I don't think I cut this. I think the knife dragged a little weird. No, I did cut it. I just saw the other piece. Hello, a new project. So I suppose you finished coding the adjustable sound wave generator? No, I did not. The things that I need to do are incredibly boring, and typically I don't concentrate on a project the way we did with the VCO. The VCO is a sort of one of the building blocks towards the greater functionality of the synthesizer. I decided I wanted more voices, so we did a chord VCO and a regular VCO. The regular VCO is needed for the chord VCO. I had to get that rolling because the circuit boards were in and ordered, but we're taking a minute to make a filter, and then I want to also, once the filter's done, I want to take a minute to work on Burn the Subs, because Burn the Subs has been sitting idle for a little while, and I need to make some progress on that. But we jump around with projects, and typically I try to keep the variety going. It's just every now and then I need to focus on something so that I can actually complete it and have a win under my belt, because otherwise chat gets real belligerent with the fact that I never finish anything. But we try to keep variety going. The reason that I'm taking an aside to fully explain that to you is because it explains it to everyone at once. So don't feel singled out by that. Avoiding the puddle. Oh, I guess, yeah, that would be a common thing that I would do that in chat, is call him avoiding the something. Avoiding the solution to the puzzle. Avoiding the MP5 on the wall. All right, so what we're doing is I'm putting down a little bit of gel control super glue, and that's not to permanently hold it there. It's on a piece of Captain tape for F's sake. Why? I can say fuck. It's just advertisers don't appreciate it. And fuck advertisers. So anyway, I'm putting down a dollop of gel control glue that's going to hold that chip in place while I solder it. That's pretty much all it needs to do. This is what I call live bugging. Dead bugging is when you take a chip and you glue it down upside down. But we're gluing it down right side up. But it's a good way to put surface mount tech on your, small pin pitch surface mount tech on your perforated prototyping board. And I like the gel control thing. Every now and then there's that Reddit thread that comes up where they go, this is a freaking ripoff. Look at how little glue you get. Well, read the packaging, my friend, because this isn't necessarily that much more expensive than a regular tube of super glue. Inside of here is a normal sized tube of super glue. You just get so much control with the larger packaging on it. That's why I buy it. And when I'm done with it, I make sure to recycle it by punching it into a dolphin's blowhole. My beach visits are very raucous. So, okay, that super glue is drying right now. I need to stop trying to be funny and actually put this thing down. So pin 1 is now in the lower right. And I will just drop this guy just like this. Actually, I gotta push down on it. Here. Why is it still moving around? Oh God, am I stuck here until it... I would like to remove my finger from this whole thing, but... There we go. Okay, that only took a second. So superglue hates heat. So when we solder to this thing, we'll probably be releasing the superglue in some way, shape, or form. But that doesn't really matter, just so long as it's held in place. And then we can run wires to all of these pins surrounding. If I really want to save space, I could go horizontally with this one. These are just the weird little techniques that you pick up when working with this kind of stuff. Now, before I even do anything like that, let's check to see what is going on with the circuit. So our frequency input comes from a potentiometer, which this will be off. We'll put this somewhere else. Maybe we'll put the header up at the top for the 3 potentiometers. So that would technically be 9 connections This one shares a ground, so that's 8. This one is 12 volt and ground, and we could probably put those resistors more locally to the pot. So we could make this one just attached to the plus and minus that we bring over. So that, hold on, so that's 3, that's actually 4, 5, because we actually have to bring that out. And then over here, this one, 7 pins. Okay, hold on. 1, 2, 3, 4, 5. Yeah. 6, 7, 8. That's gonna be 8 pins. That's almost pointless. Okay, well, whatever. Maybe I could just do wires directly over to it, but let's not worry about that. We're building this part of the circuit. So I'm gonna need a 33K coming in and a 10K up there. This is coming from the pot, and then this one is coming from the frequency CV, which is the one up there. So on my circuit, I've got this guy right here. This would be the plug for the frequency CV. I think this is the input, so we'll use the top one for that. I could have probably tucked that in a little bit more and actually built the circuit like down here. Yeah, who has that kind of foresight? Not me, that's for sure. We can probably put the diode ladder over here. This is a weird circuit. There's a lot of stuff that goes into this, and it's going to be kind of strange. Well, we'll see what we cook up. I'm not going to... We're doing kind of a challenge mode where I'm going to put this thing together, and whatever I've assumed goes where is just going to go wherever. Oh boy, this is going to be crazy. Well, let's just get started. So I need a 33 kilo, or sorry, not a 33. I need a 10 kilo ohm. Okay, we've got plenty of those. Those are actually right here. They're right here and available, thanks to my disorganized shop. So which one is the working pin from these headers? That I can reference a circuit board for, and the circuit board reference is sitting right in front of me. I can take a look at how this is done. Yeah, see, like these have like just structures that go straight out from them. CV in. The two that are close to each other are ground, and the one that's further away is going to be our signal. I'll probably have to wire those to ground too, so that when you unplug it, it doesn't have like some kind of a nasty float going on. So those are ground, and this is input, and so that input gets a 10K. And then it goes to the negative of the thingy. So we're using those pins on top. For that, I need the data sheet, which I've got. I can see, you guys can't. So this is VCC plus. This is out. No, that's really inconvenient, actually. This is in minus and in plus. If I flipped it around, what would then happen? If I flipped it around, then it would be VCC minus. No, it would still be VCC minus, and then it would be plus minus, and I'd have to hook up here anyway. So yeah, this is positive power output, which we'll have to give a little bit of room, and then the minus in is here. So we're going to be going from here to here. So I guess I might as well just put this up here and jump it vertically. That'll give me a little bit of room for power stuff over here. Maybe I can put the decoupling capacitor right here, and then I can have a wire on the other side of the board come over to the minus pin. So that'll go right there. What's that doing? Why is there another one? Get out of here. You get out of here, 10K. These Haji Wo designs, this Haji Wo, the YouTuber, he makes some pretty good, very simple designs. I like his designs. They're very easy to build. I'd suggest that everybody go watch a couple of his videos to encourage him to make more wonderful synthesizer modules that don't bust the bank. This stuff can be really expensive. Julian spends hundreds of dollars on this stuff in order to make his synthesizer a reality. In minus is going to be the junction of a bunch of different stuff, and some of that's going to be coming from external areas. I guess I could do... Well, there's also the 10K feedback resistor that goes from the output here to the negative input here. So let's get another 10K, unless there's one sitting around. Nope, I shouldn't have put that one away. I shouldn't have done it. Should not have done it. See, I talk about every single fleeting thought that enters my head while I work on this stuff. So you guys get the benefit of being able to see what goes into building a circuit like this, but at the same time, that slows me down. So 103, 10K, I can put that, well, it's going to be between the output pin here and the input pin there. It's probably better that it goes this way. I can bridge these and use this area for power though. Yeah, that's what we're going to do. So I'm going to put that right there. Move that aside while I prime the pin. What the? These fucking things. These chip resistors love to sit on their text for some reason. And so it only took the mildest of poking from my solder in order to make it flip over instantly. It's so annoying. I guess it's probably because the resistive material has weight to it. And so it balances it. It's like a piece of toast with jam on it. Okay, the thing that I planned out doesn't make any sense because this is output. So this has to go here, but then not to this. The other side goes to this. This is the negative input over here. So I'm still going to have to run like a jumper there and just jump it over. So I will do that. Now, this method of building stuff gets kind of sloppy, so don't expect great results. As we add wires and complexity to this, it's gonna balloon outwards. There are boards that will help you build op-amp circuits. You can actually make them decently neat. I mean, it's still gonna require some bodge wires, but they do exist. There are ways that you can clean it up. The output goes to a 33K, so I need a couple of 33Ks here. So let's get that resistor out. I'm using the resistor books for this. I have my own 0805s for these boards. 0805 is a good size to jump over the 0.1 inch spaced vias on your typical perforated prototyping board. So that makes for a good little project. We can sit at the bench, we can scratch our balls and figure out what the heck is supposed to be going into this thing. 33K. 3.3. I don't know. We're doing 33s. These are, so all of the math in this thing is like 1/3 of this, right? So you got 33 to 10. So 1/3 there, or 10 to 10. So 10K to 10K. It's the kilo ohms makes the current very low, but the evenness of it makes it a unity gain amplifier. And so on the other side, you have 10 volts, or you have a voltage divider, you have this, that, the other thing. It's all, you know, in the numbers. So 33 is a pretty common one when we're doing this stuff. This goes up to 27. How dumb. I'm going to need some lower values, so I'm going to keep that one up. I would advocate against organizing your resistors the way that I have. I think at some point I'll just pay the money and get a bunch of these, another one of those booklets that has all the resistors in it. Because I had one for 0805, but it was so badly organized that I decided to take it apart and put it in these. But these are so unwieldy. It's better to have the little notebook that you can flip through. The sample book, rather. How many 33s am I going to need in this immediate area? 1, 2, 3. 3. 3 of these. And I'll need another 10K on ground. So we get 1. Oh, come on. 1, 2, 3. You put all those down. Oh yeah, what have we done so far? We put this one down, we put this one down, and that's it. That's all we've done. I'll cross out the actual circuit connections when we make them. Okay, so 33 on the input, so that'll go, well, that goes to the potentiometer, but I guess I can put that one vertically. Well, that one's over here. There's just a giant hole in the board right next to it, too. Just don't drop it in the hole. Don't drop that. Dun, dun, Don't drop that. Dun, dun, Don't drop that. Dun, dun, Nobody gets your stupid meme jokes. All right, just right here. All right, give me the resistor. Thank you. Hold on to it. It did. It's barely held on to. 33, and then there's the 10K, and then we've got this one here that goes to the same thing over yonder. So I'm gonna have to jump around and go here with that, which will be okay. That'll be okay. If I were building this on a PCB, I would put one of those protection capacitors on it. I guess I still could. If we run into them, they're in one of the bins. If I run into them, maybe I'll grab them. But we've got room over here. This is going to get a 10K on it. So let me get a 10K out and do that. A lot of 10Ks in this design. I'm going to put all the resistors on this board just because I don't want to put like a through-hole resistor in line with the potentiometer for the simple reason that there are almost all of these potentiometers need their own unique inputs. They're not all just 12 volt to 0 or 12 volt to ground or whatever, plus and minus. They use all of them. There's 3 of them. They use all 3 different. I would save 1 wire if I did it that way, so I might as well just run the extra wire and have them all connect directly to the circuit. Now, by directly to the circuit, I mean I'll have a row of pins at the top where they'll all connect. And I'll leave enough wire that I can separate the 2 boards. Because I'm nice to myself, and I don't like suffering. Yeah, if you're getting into like electronics and like even if you're doing research, you may end up needing to do work like this. So it's nice to be able to show it off on Twitch. Maybe you guys will learn a new technique here and there, or just learn how janky things can be. Actually, to be fair, if you're like I used to work at like a bio lab where they did like bio research, mostly optical non-invasive stuff, but like they were building electronics on the regular in this style, sort of. Boy howdy, $5 circuit boards sure could change that whole process. And you don't need to know all that much about like circuit boards and stuff in order to make your design a reality. A little bit of EM theory would go well with higher speed applications, but it is crazy the stuff you can accomplish with the cheapness of circuit boards these days. Let's do that. That'll be good. I guess just to do a piece of wire straight across too. I like to put that fold in there because there's more contact area, and then if I need to like solder it again, it won't drift into stuff. So this is just ensuring that future bother doesn't accidentally get really angry at his own circuit. Now this stuff heats up so quickly that I have to be quick in soldering it together. Oh, it looks like I succeeded. Although I don't really trust it, I still want to run solder on it. And as soon as I heat it up, the whole thing becomes molten solder. And so the surface area is going to really influence. Why is there so much dog hair on this? I swear, I need to run the vacuum on every surface in here. That's going to be part of spring cleaning, is getting rid of all the tufts of dog hair that are everywhere. Every single surface that faces upwards gets the dog hair treatment. Every single one. That dog sheds. And it's only going to get worse as things get warmer. I should brush her. Is that still a solder bridge? What happened here? No, there's no solder bridge. There we go. All right. And then I guess I need to do from here to here to here. Although maybe I should do that by going through the board with a shielded one, because that needs to come around to here. Unless I move this over here and then I go from here to there, which is also totally viable. Yeah, maybe I'll move it over just so we have everything in one place. It looks more like the schematic. So I'm going to move this as the junction between 1033 and 10. 1033. Where's the other 10K? This is the 10. 1033, 10, and negative. Negative 33, or negative 10, 33, 10. Okay. Too bad I couldn't build it right here. That would have been convenient. What is it? There, there, there. And this goes over to here and there. So I need to solder, I guess, this side, but that'll need a wire on it. There's a balance between making it look like, kind of look like the schematic, kind of communicate as a sort of environmental storytelling manner of circuit, and having it be efficient. Why are we smoking so much? That'd be a neat way. If you had a circuit board that had a lot of like excess space on it, you're still within the limits of like the 100mm $5 circuit board limit, and you had this circuit that was going down, it would be kind of cute if you, and I think, you know what, I might have seen this before. You make it basically look like the schematic, where you have a silk screen of a resistor, and then in the middle of that resistor symbol is a surface mount resistor. That'd be kind of cool. Get a bunch of people in work outfits and get them all together in a conference room. You guys breathe all the same air. Enjoy your Poseidon event. Where's it? All of my chat windows have something over them blocking it. I've got bad habits. As an owner of cats, I deal with the same thing. It's incredible the amount of hair that dog produces. I don't know what her deal is. She's a corgi, you know, that's just what corgis do. They shed. Water falls from the sky, corgis shed. These are just things that happen. I don't like that. Okay, hold on. I think I'll solder it straight down, and then we'll bend it into place. So let me get a little solder on that pin. Sorry, solder on the pin. Solder. And I guess there's going to be another 33K coming out of this thing. Later, Ribdog. Hey, thanks for dropping in on the YouTube channel. I appreciate you guys very much. Trying to make a name over on YouTube. My daily uploads being what they are. My tedious daily uploads of the steering wheel project. I don't know what I'll do when they catch up to the VOD, but man, I started at 350 videos and we've gone down to 180. And there's been daily uploads and they're still going. Should I use the tweezers? I might need the tweezers for this. Grab the tweezers. There's a portion during projects like this where the wire starts to piss me off to the point where I start considering other options for constructing the circuit. That went so smoothly right now. I'm in shock. All right, down like that, and then I'll put the knife down right there and cut that, because it doesn't need to go anywhere else, and we can drop in on that from the side if we need to. Actually, we don't, because we're going from here. It must have heard, yeah. The wire knew that it was under threat. You better comply. Those $5 circuit boards are starting to look like they're worth the effort. It's so easy to slap together something in CAD. So easy. We're building with our hands. Because we're good at this, right? All right, so there's that junction. So that's this whole piece here. That, and we got the 33K in there. We don't have this potentiometer yet. The output 33K, and then the other side of the 10K. So that'll be another 33K, which are, I think they're these. Those are 10s. Let's just make sure. The cool thing about 0805 resistors is that you don't need to memorize a color code or some racist, what is it, acronym that some total fucking douchehole came up with back in the 1950s. God, do not type. If anybody types any of those into a chat, I'm gonna have to time you out. Because they're disgusting. There's the misogynistic ones and there's the racist ones, and then there's just the normal ones for memorizing. I think is it just Roy G. Biv? But the color coding on through-hole resistors pisses me off to no end. It's straight up memorization and I hate it. The cool thing about 0805s is they got plenty of room to print the number directly on the chip. And so with the number directly on the chip, all it is number, and then the number of zeros after. So this is 330 with 2 zeros. So 33000, 33K. So the 33 kilo ohm resistor, we know it is what it is, even though I just picked it up off of the desk. We don't have to also have the debate about whether something is blue or violet, because all of our eyes don't work properly because we've been staring at small things our whole life. Go outside and look at something far away. Do yourself the favor. I got diabetic eyes. I got trouble with some colors. Actually, for me, it's yellow-green that I have trouble with. Yeah, these are nice and easy to solder. The through-hole resistors, you have to go through a whole rigmarole of putting the thing through and bending the leads around, and it becomes very irritating with. I mean, through-hole also hurts when the circuit board hits your hand. Like, there's all kinds of reasons that I dislike through-hole. Surface mount is so easy. Everyone's afraid of it, but it's so easy. Now, if I were doing more little structures of resistors like this, I might want to go down a size to the slightly smaller, not 0805. I'd go to 0603, which is a perfectly large and solderable size. 0402 is evil. Evil small, because your resistors no longer have markings on them because they're too small for them. Another cool thing about surface mount is if I hit this with hot air, everything will reorient itself to where it needs to go. Now this is a fairly complicated chip. What is this? This one is input. Input, I guess, can come down and knock over to the side like that. This one is the 33 that goes to the, this one is the 33 that goes to the connector. This one is the 33 on the output. Okay, so we only need to connect this to this. So I got a little bit of solder on the pin. Hopefully I can get this down. Yeah, a little while ago, because I wasn't fully aware of all of the shitty, really shitty acronyms that they have for the color codes and resistors, and chat thought it was real great to have a discussion about it, and I'm trying to stop them, and people are putting in the acronyms and stuff into chat, and I just had to ban a bunch of people that day. I think they got unbanned, but still, it was just like, don't do it. They're all perfectly capable of looking that stuff up on your own. You feel like polluting your search results. The output is only shared between those 3 items. So yeah, we've got all 3 items right here. So all I need to do is bring this over like this. Do I want to kick it to the side? I think I do want to kick it 90 degrees. Let's kick it 90 degrees just by putting the pin tool down like this. Yoink. Ah, damn it. I screwed it up. See, now that little runoff is, this isn't fully soldered in. I'm going to have to run the solder again on it. And just give it a little, eek, a bit of the old English. Sure, let's start over. Bye. Get the heck out of here. This stuff is pretty fiddly, and it's what we had to do before we were able to just get, like, go and buy circuit boards. I'm actually going to tin this with this pin over here. Probably shouldn't do this because these Donkey Kong connectors are a little bit fragile. But if I just give this a little bit of solder on the end, that's going to make it easier to solder to this post. That didn't actually work. Okay. Get this. I can do this. Like I said, this style of soldering stuff is sloppy. It's going to look sloppy. It'll get the circuit, the business of the circuit done. It's about the results. I feel bad because I made a trophy for a boss in the at the IED job using this technique, and it looks terrible, especially if it's on an award. I had to make like a little game on the award. Who the hell are we billing this time to? Like, it seems like a bad use of my time. All right, so right here. Okay, there's that part, which means we're done this. Which means we're now over here, or, well, we still have to do this. So let me go do this one, and I won't do the ground connection. We're pretty much, well, what I guess what I could have done is just draw over the parts that we did, yeah, and just be really specific about what we've done. So done that, done this. I've put in this part, and I've wired this part of it. I haven't done that other part of this. This one I've done, and then this up here we've done. Oops. And we've done this. And we've done this. And this one is in too. Think of it as people. It ain't got to look pretty. It's just got to act right. Yeah, I guess so. That's one way to look at it for sure. Let's do this line right here, and that's going to require a shielded cable. I guess I'll just use white wire. White wire will do. Nice little contrast there. What I do is I pick off the end, either with fingernails or an actual wire stripper, depending on my mood. And then I'll tin this. When I tin this, that wire is going to retreat a little bit. The tool that I lack, the thing that I would really love to figure out one day, and it's becoming less and less necessary as these types of circuits are obsolete. Again, $5 circuit boards. But what I'd love to figure out is a pair of tweezers with nichrome wire on the end that I can use to pinch and then pull back on these things. What's up, RYG? What are you doing on YouTube? I mean, I guess it's always good to have YouTube chat be active. Come back here. I would, yeah, just like a pair of tweezers with that just hold little nichrome wires on it that'll heat up, and then I can use that to strip off the end of the wire with very, very low force. As it is right now, what I'll do is take the wire and heat it up on both sides with the iron, and that's really sloppy. It really makes for a sloppy connection. Yeah, my one viewer on YouTube. Actually, how sad is the YouTube section? I don't want to look, but at the same time, it's like looking at a car accident. The YouTube channel is not really picked up all that much. I guess I could do more stuff to try to pick it up. Concurrent viewers, 2. I got 4 likes though. That's pretty nice. It's nice of you guys. Thank you. I appreciate those. You guys are all great. One day we'll pop off. Plenty of people on Twitch though. Plenty of people on Twitch. And I'm glad you guys enjoy hanging out with me while I do stuff like this. You're very motivational. Twitch is very motivational. When you stream projects, things get kind of serial. Coming in from the side, I guess that's all right. If I go up to this one, or I can just go down to the other one. Yeah, let's do this first. So I'll go down here like this. We gotta get the board up. And then go to across to the center hole of this. And it doesn't have to be across the same plane, but I guess it's all right if it is. And I like to be able to see the color of the wire that I'm using, so I'll leave just a little bit of a gap there. And then we can see that it's a white wire. Push that down with Twizzlers. The only problem is the heat of the soldering is going to make the jacket of the wire extremely melty. So I've got to be kind of quick, and I don't want to push down on the jacket of the wire. I want that wire to be down against the board just for cleanliness purposes, and I want it to solder properly, but I also don't want to have pressure on the jacket in any dimension. And so if I want the wire to come directly up and go right to a pin, it will end up extruding. It'll act like a foam cutter, the wire will, with the gloopy jacket, and it'll end up splitting the jacket as the jacket wants to return to its original orientation. Oh, there ain't nobody on Twitch. Nobody's active. It's a bunch of people who left their computers to go to a meeting. One meeting or another. One meeting at a time. All right, so this is going to go right like that. And so I'm going to pop it right there. Ah, my whole board fell down. I really wish I had a little step on the edge of these things for the circuit boards. Oh, Spicy Corsair is still here. Wow, what a loser. I'm just kidding. Thank you. Thank you for still being there. You're always keeping me sane. You're keeping me sane. RYG came over, stomped over from one conference room to the next. The door labeled Twitch and the door labeled YouTube. Gonad and I were thinking earlier and talking about doing, like, if you did a multi-monitor stream where one of your monitors is on one channel and then you have a different channel for your other monitor. Be a lot for people to experience. See, the only good way I have to do this is by heating them up and then picking off all of the plastic goo that it forms. It would be kind of cool if I had a set of tweezers that were heated. I don't know how I'd accomplish that and make it nimble enough to get into these kinds of circuits, but it sure as heck would clean everything up. It would make my circuits that much cleaner. I mean, what you would have 2 heaters, and each heater would probably have like a plate on it, or like just a little pincer thing. And so you could just do it that way. Could you cut a holding line in the vise with a Dremel to hold the board still? I wouldn't want to do that with a Dremel because, yeah, melty. Everything is very melty in this. With this technique, you get burning and melty. I wouldn't want to cut it with a Dremel because the Dremel is like super inaccurate. This is a precision vise, and actually, the only reason I wouldn't call it, it's also a palm ground, which is like a big name in machine vices. This is built to be super precise in its dimensions and stuff so that you can put it on like a flat surface and know that this is indexed with the top of the vise. Like, that's how precision this thing. This is a $600 vise new. I got it from some estate sale. So it's obviously not worth that anymore because of all the wear and tear that it's had. If I were to cut a little shelf, I would do that with the milling machine, and my milling machine is not accurate enough to really do that kind of tool and die making stuff. Maybe it could be. It's the same milling machine that I think ClickSpring has. The Sieg X3. But it's not, you know, I'm not inheritance. Well, I mean, I guess I am kind of inheritance machining. But it's not my relatives. It's just people at estate sales going, hey, I got a box full of electronics. You want to check this out? And I go, hell yeah, brother. And then I get a bunch of cool stuff. That really is the best way to get like nice tools, is when somebody with nice tools dies, you absorb them. You absorb their power. You do a big power up scene as you go, ah! Okay, so there's that connection. That was easy. So I'm gonna say we did that one by just drawing over the line. Let's see, this one's in there too. We haven't done the connection to ground. That's up there. Let me just do, well, first of all, I'm gonna need a 0.1 off on there. That one's not in all of the schematics, but it is something that we need to do. So where are my 0.1 oof caps? Finding the parts is a lot of the time spent building. Being very organized helps out greatly. I'm only sort of organized. I really should keep the 0.1 offs next to the 10Ks, shouldn't I? Although one of the divisions of these bins is actually 0.1. Jaw covers with a step. Yeah, something like that. But then I'd need another. This is not a big vise, so it wouldn't. On some of the circuit boards, like especially the modular synthesizer ones, they can get so wide. Like right here, I've got only this much room in my vise anymore. 0.1 off. Is that going to be? That's going to be in these somewhere. Here are the caps. 0.1. Oh yeah, there's a ton in there. So we only need one. The purpose of the 0.1 off cap is to allow stabilization of the power before power reaches your device. And it'll take up any transients on a very small time scale. There's been so much frickin' activity at the front door today. I don't know what is going on. This is a frickin' brothel here, or people coming and going. I just heard her run. I heard my dog run full speed towards the front door. She's got a bum leg. Like, she shouldn't be running. You can't help it. The dog's gonna dog. She got that dog in her. I don't. You guys probably couldn't hear unless you're on headphones. But she goes brrr, and then there's scuffling across the floor. Usually she'll sleep at the entrance to the basement because her bum leg keeps her from going up and down stairs. So, and I think she likes my smell coming up through the basement. She's a good guard dog. I got that Ring doorbell thingy because I was down here like alone. There was nobody else at the house. Everybody is at the house right now. That's why things are so busy. But I would be down here alone, and I need to know, like, if a package is coming or if somebody's at the doorbell, like, what is going on? I have no situational awareness of things going on upstairs. So I got this Ring doorbell, and I got the lady who shall not be named to display the doorbell and all that stuff. But then we got a dog, and all of those problems evaporated in a flurry of But yeah, what happened to her leg? She was out playing with her friends, running full speed. And dogs are not very well designed, and they have, unfortunately, problems with the tendons in their leg, the ones that keep the leg from going front to back, the joint of the leg from going front to back. And I guess it was stretched tendon, which is really unfortunate, and it may not be something that she can heal from. our neighbor dog had a very similar injury to a very similar dog system, and it did heal after a bunch of weeks, way too long. The dog eventually just snapped back and was totally fine. I don't know if that's going to happen with Willow, and this is a pretty common dog thing. Pretty common dog thing, unfortunately. I feel terrible about it because she's not even 2 years old. Not even 2 years old, and she already has a permanent sports injury. Apparently, she was at the vet. She was 38 pounds, and she's not fat. You can almost feel ribs. Corgis are supposed to be 30 pounds. She's 38. I think she built a little bit of muscle. I think we have a bodybuilder as a dog. She loves to run, but she can't run because of her bum leg. So we may be shoveling out for a big surgery. Thin sheet of aluminum with small bends. Oh, for like a vise? I don't really need that. But a bend in the aluminum in order to hold the board. Would you do like up, out, and then up? I guess that could work. I would rather mill it out of a big block. That would look better. I guess I can take... How would I do that cleanly? I mean, take an end mill, obviously. But that wouldn't... I'd need like a big spring at the bottom of the thing. I don't know about that. Then again, I could make my own jaws. So I could take a piece of aluminum and I could remove this jaw and I could make a jaw that has a step in it. Or I could even put the step in the top of the jaw and the jaw would be flippable. Although re-indexing the jaw would be very, very annoying if I was doing... I don't really use this for machining though. This is mainly a soldering tool. But then I would have to mill steel, which I don't like doing. No, the Z-shape wouldn't work, because if it went down, over, and down, then it would just pivot on this, and it would end up... Well, if it was close enough to the top here, it wouldn't want to pivot. But it still would. It still would. I gotta rebend this thing. What I should have done is solder this like that, and then, well, I could still do that. It's hard because I have as much view of the third dimension involved in this as you guys do. We'll get our power from right there. This looks a whole lot like the circuit board design. Jeez, I think my puppy got to spend some time with her friends because she is on the warpath today. A lot of barking going on up there. I guess it is garbage day too, so those unruly, evil garbage people are invading her territory. Her territory! Let's see. What are next? We need to go from here to here. Oh, your garbage day is Thursday too. Oh, which one is that? So I go from the bottom, and then I'll need to do that little jump right there. But we go from there to there. Okay, so the bottom one to the bottom one. Bottom to bottom. Ace to ace. Oh, yeah, let's just put the plastic right where my arm's going to want to be. Ah, okay, hold on. Let me figure this out. So that's our start, and we're going to go straight down there. I can't really orient this properly. I need to... I want to come in from this side. This circuit is not built for my right-handedness. Just going over to there. I'll need a little bit of solder on the top here. Hopefully the ladder, the diode ladder is not going to take up too much space here. I mean, it's a lot of diodes. It's 12 diodes, so yeah, it probably will. And it's got a bunch of capacitors too. So wherever that part of the circuit ends up is going to be a complete mess. I guess the caps, I'll probably, well, I'll want them to be on one side of the board. I don't know if we'll end up making them on that side of the board. We'll just figure it out as we go. We have no significant plans on how exactly this is going to be constructed on a perforated prototyping board. The last time I tried to plan... Damn it, what? Oh, I'm trying to add wire instead of solder. This is getting confusing. The last time I tried to organize a perforated prototyping board to build, I got a 3D model of perforated prototyping board, and I was going to go into the CAD software and try to plan out where all the components are supposed to go. And I just ended up printing a circuit board because it's way easier than planning out a perforated prototyping board. Now there are online tools that'll help you plan out a perf board, but I don't think they have things like Funky Kong connectors and, you know, some of the weirder parts. I don't really know. I haven't played with them very much. So there's our ground line going over like that. And then we just do a little L shape here. Where's oh, we're going the wrong way. Wrong direction. Remember that I have the hand cam going, so if you don't know what's going on, if I'm off frame with something, you can see what I'm doing in this camera here. If you want to see where all the heat is, you can see on the thermal camera. I need that. I need to get like a lens so that'll let me make a thermal microscope. That would be a really cool thing to have. If we had this view with the same amount of standoff, but it was thermal, it'd let us see a little bit more resolution into what's going on. All right, just take this and go like this. That did not do very well. Curse you, third dimension. You've made a fool of me for the last time. I now exist in 4 dimensions. I age. So I saw a little bit of Hamilton. I didn't get through a lot of it. It was whatever that Disney thing is. I feel like it's battle rap for theater nerds. I said that in my Discord and nobody was paying attention to me at the moment. And I think everybody's over it by now, but a lot of people really liked it. I watched a little bit of it and I wasn't too into it. Maybe it just wasn't for me. And try to catch up on a bunch of stuff too. Saw Good Omens. I thought that was pretty good, although I have done the usual obsessive thing of dropping into the subreddit for whatever media I've experienced. And so I dropped into the Good Omens subreddit and looked at what the discourse was over the, 4 years that it's been around. The TV show, rather, has been around. There's a lot. There's a lot. And apparently there's a lot going on screen that I'm just missing out on. Because I guess it's a book adaptation and Neil Gaiman is directly involved, and yeah, pretty crazy stuff. It was fun. David Tennant's chewing all the scenery. It's perfect. Yeah, that's one that I'm gonna have to revisit and watch again in order to catch some stuff going on that I didn't really catch the first time around. There's a lot of nuance to some things that happen in that show. What else did I do? Invincible, I caught up on. that's like a neither here nor there. Frank Darabont's very good at what he does. They're doing a decent job adapting the cartoon. There's not much to say about it actually, which you know, that's not a bad thing. It's perfectly entertaining. It's like a comic book. All the subversion of comics things, like Superman is evil, woo, it's just a non-thing these days. All right, how's my soldering? Is it super duper sloppy? It's okay. It's okay. It's as good as I can make it. All right, so what we've done is we just did what's not shown, which is the plus 12. Should the capacity, I guess so, plus 12, doot, minus 12. And then we did plus 12 and minus 12. That's ground. Minus 12 is an arrow, and ground is an open arrow. And then you label it just to make sure that there's no question. And we also did 10K to ground. And this is what, that's to ground. Wait a minute. Oh, I've already screwed up. I screwed it up. I messed up. That 10K goes to ground. This is why we're methodical about this kind of stuff. This is why we do what we do. So what I need to do is get the solder off of the 10K resistor and remove it from this part of the circuit. And I'll pull it over to the side where we can attach it to ground. Luckily, there's still room in this area. All right, so now that 10K is no longer connected to where it needs to be because we pulled that with the surface tension of the solder, we pulled the wire away, so we need to just start over in this area. Everybody go away. This is my stream, go away. Where'd the solder sucker go? What did I do with it? Oh, there it is. I was like, my boy. Where's my boy? I probably need to redo the tip on this thing. It's starting to get a little grody. Luckily, the solder sucker is just a piece of 1/4-inch silicone on the front, silicone tubing. You can buy clear silicone tubing. Or you could buy directly from this company their little piece of silicone tubing that they try to sell you for an amazingly large markup. So instead, just get your own. $10K? $10K. Glad I have a little supply of these. Yeah, it's a good one. Wexo was incredulous to the fact that I was annoyed with most solder suckers. I was like, solder suckers are terrible, don't use them, right? Which was a perfectly fine opinion if your only exposure to solder suckers were the ones that typically come with electronics, the big fluorescent ones that have, you know, typically like Hakko makes them and some other companies make them, but they're big, like McDonald's looking things, and they're terrible at their job. They're very bad at it. They do not do a good job. You know what? I'm not going to do that directly. I'm going to do this right like that, like I had it before. Is it properly? Yeah, okay, so that should not be connected to -12. So the decoupling capacitor goes from positive to -12, but this 10K here goes to ground. That's an important distinction because ground sits in between negative and positive 12 volts. It's a kind of an important thing. Oh, this thing wasn't soldered at all. Come on, hey, damn it. Cursed thing. There's gonna be all kinds of like solder bubbles on the other side of this, just because the solder tends to wick down with gravity. It bulges down with gravity. It bulgy-wulgies down with gravity. Downward it bulges with its bulgy-wulgy. I'm gonna stop talking now. All right, so let's do this. Other pin, and then I gotta get a little tiny piece of wire in there. Just a little tiny little bit of wire right here. There we go. Okay. Yeah, there's gonna be big bubbles down there. Why did that move so much? What the hell? Jeez. Okay, well, That's definitely in there. Let's see what the other side looks like. Oh my god. That's not too bad. Not too bad. All right. So let's see. Tighten that up. Check my glucose level. Oh, I don't have an overlay here. I thought I did. Oh, it's in overlays. Wait a minute. Overlays, and then BG should be in here. Oh my god, where is it? No, it's not in here. I have that. That's a forklift. It's the freak show. It's a party line with Freddy Freaker. Okay, get that out of there. No, that's definitely not it. I have some stuff left over from jokes from a million years ago. I guess go here and then all the way down, all the way up. See, the other overlay that I had was more clear. I guess that's on the arm view. All right, so my pump is desperately controlling things, which is nice. And as my glucose level gets more normal, I don't burp as much, which is good for me, because that means that I can still talk to you folks. So yeah, we're still building the circuit. We're still putting this together piece by piece, methodically, and getting everything on there except power, and then power will run just via wires to everything that it needs to go to. So this little line right here is what I need to, oh, Jesus Christ. That's what happened. Well, we can cut around that. That is so this is what happens when you're waving the soldering iron around and you don't really see stuff that's in your way. And again, this is why we run from smallest to largest on your typical circuit board build. On your typical circuit board build, if you've got like an actual printed circuit board, you will do it from the smallest to the largest, and that avoids your soldering iron colliding with plastic in this way. In order to fix this, because it is perfectly fixable, all I'm going to do is just use the side of the plastic as a guide for the knife and run the knife along the side until it's smooth. And so it'll just be a little chunk that's been taken out of this connector. It adds character. Ow, it also adds spiky stuff. It gives our synthesizer a little bit more personality and a little less functionality. We've all done it. You can't judge me. I just have to whittle the plastic away. Which a good sharp scalpel, not X-Acto knife, is very good at doing this, at whittling away plastic. It's also really good at cutting flesh. That's why they cut flesh with them. So you got to be a little bit careful about cutting away from your spongy, fleshy, gloopy hands. I should have been a surgeon, but I'm pretty squeamish around large amounts of blood. I'd be the guy pale-faced during the dissection, whereas my lab partner was the guy that would puppeteer the frog. Okay, and then over here, I'm a little bit more steeled up in my reserve these days, but like back then, I couldn't take it. All right, perfect. There we go. So the soldering iron thing, I've got to keep an eye out for. That was why there was so much smoke coming up off of this thing. Yeah, there's all the plastic too. I can get that off with a dry sponge though. That'll just scrape that off a little bit. That's cleaner. Yeah, there we go, nice and clean. I don't like to have plastics burning near my face. All right, so we still need to put that little piece of wire in there. That seems to be the impossible task. I just have to watch out for this power connector from now on. I probably shouldn't have even put it in. I should have just, you know, marked out that location. Or built on the opposite side of the board, but then I would have the 3 Donkey Kong connectors to contend with. So I just need a little tiny piece of wire in between those 2 points, which is not an easy thing to do. I think I could do it though. You know, you could solder bridge between the two, but I think that's a little sloppy. I'm gonna use this one to tin my wire. There we go. Oop, give it back. Well, I guess that's good enough. I guess so. All right. Good enough is what we aim for today. Be nice if I could fully round these off and like fully finish them. But the ground and power runs, I guess, are going to be based on where things are located. So what we have is just, we've only done that connection right there. We haven't even connected the Donkey Kong to ground. And then we've done this one right here. No, we haven't even connected it to ground. We just put this down. All this just to make that accurate. All right, so 33, and then we've got another 2.2 to ground sitting on the 33, and that's why I didn't put away these resistors over here. 2.2 is right here. I wonder if all these values could be tweaked depending on the silicon lottery that we have partaken in with our components. So, all right, so this wire jumps around, goes to here. This one is a 33 kilo ohm coming off of the input line. This goes to the potentiometer. The potentiometer has its two cohorts that'll be wired closer to the pin header up here. That's that and that. And then over on the other side of the 10K, we have a 33 kilo ohm coming off of that right here. And then this one goes to ground. Ground is also over here. Well, that's not too convenient to get to, is it? So ground is also over here with these two here. This is -12, this is +12. So I guess my best bet is just to go like this, and I've still got space for +12 to come in anywhere around here. Or I go upwards. Nah, we'll just do this. Oh my goodness, this dog is barking at everything today. I guess there's a lot to bark at. And hopefully future me can make use of this. I don't know. You actually heard that? That was as quiet as the other ones. Yeah, she really hollers. There she goes again. She's Willow. What is so important? I need to scooch this one back a little bit. I don't know if I'll be able to do that. Doing these in a box shape is much easier with square pads. The circular pads, I don't know, they just don't sit right. I guess maybe I should have gone with 0603. Those would have fit a little bit more cleanly in these little, the way these are organized. They would have fit a little bit more cleanly on a grid. These are aight. They're all right. Does that 2.2? Well, the 2.2 needs to go elsewhere, so maybe I can do, like, move it off a block. What about, no, that goes to -12 through a transistor. So yeah, we're still SOL. Here's +12. That goes into one side of the transistor with a 4.7K. So actually, probably is better if I come off. Where do you get off? This way. Where's that 333? Oh, that's from the potentiometer. And then 103 goes to the input. That's 10K goes there. That one goes to a potentiometer. The potentiometer goes ±12. Okay, okay. I'm trying to get it right. Please get off of the soldering iron. So let me get a transistor over here. I need to figure out which NPN I'm using and get that data sheet up. Excuse me, sir. Please flow over. What is going on? Why am I not? Why is nothing? What the? Help! Okay. Look, it's just not soldering. It's just straight up. What in the world? And it hasn't turned itself off. It's still on. I guess all the flux is gone or something. That or something is happening in the third dimension that I'm not aware of. Something was watching from the third dimension. Why do I feel like a bug in my hair? Huh, static electricity. All right. I felt like a bug was crawling across my hair. I have a lot of hair. This circuit flux. Please? Like, what is it doing? What are you doing? It's just not accepting the solder into its heart of hearts. And what'll happen is I'll solder this one and then it's gonna totally reorient itself. Okay, the iron turned off. I looked up and that LED was definitely on. I'm so mad right now. I just have hatred in my heart. That's all. Fills me, keeps me warm. Yeah, it's like not flowing over the whole. There it goes. There it goes. Oh, but this is desoldered. Perfect. Just what I wanted. It's like sticking up in the air. It's tombstoning on the one that I'm not trying to. Oh, so mad. So much hatred in my heart. There we go. Are you soldered now? Are you happy? All right. There. So, okay, positive 12 is theoretically coming in here. This one is open now because we need a transistor, probably right here, as the input to our giant ladder. We actually have two transistors, so they're all the same value. They're all the same type of transistor. Actually, I wonder if it would work out if I used one of those super matched quad transistors. Those are expensive though. Oh, Barhanity Tiaga. Hello. Sorry, I missed that message. Okay. Transistors. Right. I have this kit. And we need the 2SC1815, which is what Hajiwo calls for, equivalent in the BC series. And I heard BC 547 and 548 are wonderful for audio. So we'll use one of those. I have to figure out which one is which. That's the wrong screen. So which one is which? Well, we do BC 547 data sheet. Yay, assorted parts kit. I had to order all this stuff when I started on doing synthesizer projects. I had to buy all these kits of components, all these common analog things that I don't use. Oh, I'm gonna stretch my legs. I don't want to get blood clots. Bumble clot. BC 547. So 546 is 80 volts. BC 547 50. 548 30. Are they all the same thing? High voltage, low noise for the 550 and the 549. Complement, blah, 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 56 and 60. This is a multi-data sheet, so these are always a little bit difficult to interpret. And then the transistor that we are trying to put in is the SC 2SC 1815 data sheet. The central semiconductor 2SC1815 series are silicon NPN transistors manufactured by epitalaxical planar process, designed for general purpose amplifier applications. So what's going on? Oh, Lab Gluon, hello, welcome, Party of 19, how you guys doing? We are working on building modular synthesizer stuff. That would be this stuff here. This is the stuff that my buddy Julian has been after me for like 20 years to build a modular synthesizer. And I discovered that what you can do is you can order the circuit boards for these things for cheap. That's really what got me started in this. He's been after me for 20 years, and at the very end of that, he went, hey, you know, you can just buy the circuit boards. And I'm like, what? So my skills are in hardware. We do a lot of hardware around here. We do a lot of little projects that are kind of cute and fun. One of the mainstays of the channel used to be, and will be in the future, Burn the Subs, which is a big board that is sitting on my wall, and it'll burn the name of subscribers onto itself. This is not running right now because we have, the past several years, since like pretty much a little bit after the pandemic, I just discovered, the board filled up and we couldn't take any more names on it. So we've been very slowly and methodically redesigning the entire board so it'll be cooler and it'll look cool and, I don't know, do pretty much the same thing that the old one did. So that'll be coming up in the near future. But for now, in between boards and making the new hardware, because this is the control panel for the new board, I decided to finally humor Julian and get into analog circuits and modular synthesizers, and it is a whole world. There's lore behind some of the creators of these things, but I have been slowly piecing together an entire synthesizer. It's a big project. It's a lot of little projects in a trench coat. And so what we're doing right now is we're working on adding filters to the synthesizer. In doing this stuff, attracting the people that we have attracted to the stream, I have discovered that there are channels, for instance, Hajiwo, who is the creator of the circuit we're actually building right now, where they do cheap synthesizer projects, which is totally different from this. This project was probably $75 in parts. Marbles is a wonderful, wonderful piece of hardware. It can pretty much run almost your whole synthesizer. It'll create its own, you know, voice and everything. It's really, really nice. Marbles is cool, but it costs about $75 worth of parts. And since Mutable Instruments no longer makes modules, if you get one new or newish, it can be $375. So getting into this cheaply is difficult. A lot of these modules that I have currently are pretty expensive. Well, actually, the ones down here aren't, but some of them are pretty expensive to build, even just from nothing, right? I figured I'd had a lot of parts. I got parts. I can build any of this stuff. No, I didn't have any of the parts that I need to order parts time and time again in order to build these. However, Hajiwo is out there making cheap synthesizer modules, and he makes some really good sound out of them. And it's good to educate yourself with a little bit of analog. Excuse me. Oh, burp. Some analog synthesizer stuff using these as sort of a springboard point. You guys see over here is a steering wheel project. Those Raiders, if you don't know what the heck's going on with the steering wheel project, it's been sitting for quite a while. Right now I am uploading to YouTube all the VODs that were involved in creating the steering wheel system, and they're all up on my VOD channel now, but this is actual car parts and an industrial servo motor that make a force feedback steering wheel. Anyway, we're doing little tiny circuit stuff right now. Thank you, Lab Gluon. Good to see you. I take it you're from the Knowledge Fellowship. I don't know how like professorial I am. Professorial, freaking, I don't, man, you know, like, whoops. Yeah. I don't know, man. This whole setup and stuff is me doing like my own little projects here and bring you guys along the way, and maybe I can teach you guys something about building physical circuits. And I'm learning analog and you're learning analog because I'm learning analog. That's kind of how it works around here. I loosely associate with the Knowledge Fellowship. They bring all kinds of cool channels in here. Lab Gluon, Paleontologizing. Those guys are super awesome. So check out, if you want to see like a group of streamers that are a bunch of smart boys doing their whole thing, even the girls, check out the Knowledge Fellowship. There we go. There's the plug. There's my twice annual plug of the Knowledge Fellowship. what were we doing? We were looking up transistors. Take a big sip of this, hold on. If you really want to get into the nitty-gritty with transistors, I don't know how to give you guys the forest for the trees because I don't know a whole hell of a lot about doing analog with transistors. There are properties that you look for in a transistor. I use them as a switch. Most of the time. Hajiwo is using them as amplifiers. They're a little bit more difficult to use as amplifiers because you have to bias them in the right location because of the way the 3 layers of silicon that make up a transistor work. I was looking for a diagram and there's just not one on here. Transistor is 3 pieces of silicon that are doped in order to have either holes or electrons. You have a boundary condition between those layers of silicon that you can influence with an outside voltage. So if you have a voltage sitting on both ends, the boundary conditions are going to be limiting everything from having a flow of electrons through. But if you bias that middle layer, you can then have holes or electrons in the middle, and that will allow current to flow through. And then Veritasium comes in and he smacks me on the head and I get, my skull's cracked and I start bleeding onto the floor while he explains to you that actually electrons don't flow anywhere. It's the charges that allow the electron. We don't worry about that here. We don't need to worry about the base physics of stuff that much. Even the layers of silicon thing is not that important to us. What's important to us is the math behind the silicon. And that math will enable us to create synthesizer level signals with audio. Bother, how does a diode ladder filter work? I don't know. I actually don't know. I watched a video on it. Mortis Klein is another YouTuber that does very nice circuit breakdowns of synthesizer stuff in analog, and boy howdy, he has some really nice explanations that I was present for. I was there, I was listening. None of the details stuck. So I don't know. In a way, I guess it's you're using the microcurrent properties of the diode to act as a variable, a voltage-controlled resistor, because there's leakage in a diode, and that's one of the things that we can get from the. That's one of the things that we can get from the data sheet. But I don't know. So right now what we're doing is we're looking up the Hajiwo transistor, and that is this one, the 2SC1815. We have built everything that's highlighted in red, and it has taken us only 3.5 hours. Jeez, 3.5 hours, and I've only just built this. We are here, and so I am looking at these transistors. Now, this is not required to oscillate. This is not an oscillation circuit, so these don't have to be super matched. The dirtier our resistor ladder is, I think the better, because we're not trying to make super professional expensive circuits here. We are DIYing a filter, and if the filter's a little bit crunchy, then so be it. I suppose right now what we're doing is the business of amplifying a signal. So what we've done is we've taken our input signal and we've gone from 10K, 10K. So this is unity gain and then 3 to 2. So we're voltage dividing it 3 to 2, activating this at 12 volts, which would then bleed through this in some way, shape, or form. See, this requires more analysis from me, because why are these NPNs in this orientation? If we're going to be putting 12 volts onto what? Okay, so between negative and positive 12 volts in a voltage divider. 4.7, 4.7. So whatever's coming in here is allowing the positive to come through and influence this. Clear as mud. So we're going down to negative here. Ground will trigger that. What is that doing? If we're pulling this down, which this is already being pulled down through, oh my God. This is crazy. I gotta build all this crap. Okay, well anyway, the point is we need to find an equivalent transistor to the 2SC1815, right? 2SC1815 transistor. Oh, that one was on, yeah, okay, I get it now. Here's the 2SC1815. So collector to base voltage, 60 volts. Collector to emitter voltage, 50. That's pretty huge, actually. And I guess since we're in a synthesizer, we're plus minus 12 volts, that's compatible, 60 and 50 volts. Emitter base is 5. continuous current 150 milliamps, power dissipation 400. So we want something that matching these properties is not entirely necessary. I think the EBV is probably something we should look at. And all of these transistors exist on curves. Oh, come on. They're on mathematical curves. Are we given those? No, we don't get they don't give you the charts. Great. Perfect. Okay, so the ones that I'm looking at is the BC 546 and 547 because I have them, or 547 and 8. I have them in a kit. So BC 548, 30 volts. That doesn't quite match the 60 volt. Is that CBE? Collector base voltage 80, 50, 30. This one's 60, of course. So the 547 might be a good equivalent here. 45 volts, this one's 50, slightly different properties. 6 volts for the 546 and 7, and this one's 5. So yeah, maybe we'll go with the BC 547. 45 and 50. I mean, actually, the 548 is 5 for the emitter base, so that would match. Because we want it to bias the same way. I don't know what the rest of the chart looks like for it. This is what we're looking for. That one is for the BC 54, 6, 7, 8, and 9. Okay. Yeah, let's use the 548 and hope that it works out. Mostly I'm just guessing. I'm shooting in the dark there with that. I wanted to look for similar properties, but it seems like, you know, the base emitter voltage is probably pretty important to what signals are coming in from the outside. So we'll use BC 547. Okay, so BC 547, what's our pinout? And our TO92 case. Cool. We've got a number and a number here. The problem with these transistors is that you have a view like this, and sometimes they'll give you the pinout on this view, and they won't tell you if you're looking down from below or up from the top. They'll just show the pins in the middle like that. I've seen data sheets that do both. This one, they decided to number it on the front of the thing. Every now and then you'll get a 3D diagram of the transistor, and that'll tell you which one's which. The alternative to this is that I could use surface mount transistors, and those I can work with in this. But I guess if I've got the BC 54s right here, we'll use the through holes. It'll give this more of a through hole look. BC 547. I need 4 of these things. Haji will use these instead of op amps. Op amps are much more reliable and clean and tunable and all that stuff. They're a little bit less finicky than transistors. These might change their properties when the case heats up. So 2.2K, and this will be 222. 222 goes to ground, which we could pick up ground over here, but I'll do that later. 222 goes to ground. The junction between the two goes to the base of the transistor. So if I move this window all the way over so that I can work, we have like 4.5 viewers right now. You know, I'm doing pretty nicely. After the raid of 4.5 viewers, we now have 4.5 viewers. But we're having a nice chill Thursday and building circuits. So pin 1 is the emitter, pin 2 is the collector, and pin 3 is the base. So the emitter is the first pin. And then the base is pin 3. Oh, so this actually can go like this. And actually, if it goes like this, then plus 12 is here. And oh, but 12 volts, I can put a 4.7K right here. And then I can have 1, 2, 3. And then the emitter, that's the collector. Yeah, perfect. Okay, so I need a 4.7 kilo ohm resistor. Luckily, I got one right here. Bada bing. 4.7K. Let's drop that down on the board. And then I need to desolder a couple things in order to make this happen. I need to pull solder out of this junction, which I fought so hard to get solder into. I tried so hard to lose it all. In the end, that mattered a little bit. Solder is not functioning right now. Hello? Heat? Bring the heat, bring the noise. Yeah, before I was skipping around all pretty, soldering things left and right. Now it's all fighting me. I'll remove some solder from this joint. I think maybe the reason it's struggling so much is that there's just a lot of solder here. The volume of solder making it hard for this to heat up cleanly. Yeah, see? There it is. Can I get a pin through there? I think I can get a pin through there. Cool. So that's going to be where my transistor lives then. I got a couple 4.7s. Let me put that one away. I don't know how I got two. Where did my tweezers? They're there. Right, you're not necessary right now. Are there any other 4.7s? No. Oh wait, there's one right there. To negative 12 volts. Okay, so we'll keep that in consideration. Actually, that can we just park that right here. That goes from a junction of the two emitters and BCE. So that goes to negative volts, whereas this one goes to positive volts, and it goes to here. That would be a nice little trace right there. Okay, that's perfect. Perfect, perfect, perfect. We'll just store that one right here for now. Is that a little bit out of focus? Seems like it is. I don't know why that specifically is out of focus. Hold on. There may not be a large amount of light getting into the microscope right now, and that might be altering how the camera's getting its focus. Let's try this. I really need to hook up that 1 to 100 stepper motor that we have and make a little focus control for the microscope, because that'll be so much smoother and it won't be like there's a massive earthquake every single time I try to alter focus. I'm going to cut back this wire. I'll do that with a knife, but I'm going to heat up the solder pad so that I can cut that little end of wire off and fit the 470 ohm resistor on. So I'm going to go like this, heat it up. Oh, right, there's nothing below it. Oh well, now it's dropped into the hole. It's fine. I guess that'll work too. My name is Jesse, but I don't like using it on the platform because it's a little too personal. Yeah, I have an uncle with that name. He sounds very similar to me, but he also likes to use not like what is it called, like $10 words or $3, $5 words, like the real dictionary kind of words, except his are like even more advanced. It's literally just trying to speak in code at that point. Why are you speaking in tongues? Use your words. You're like a birthday card. He's got like a word that I have to go to, like I have to go to the encyclopedia that's like the one on the wall, not just the online one. What the fuck did he say? What did he say? Yeah, $5 words. They're the ones that you get $5 for using multi-syllabic, complicated words. I use too many of them for my stream. I like using big words, but I certainly am not at that level where I'm totally befuddled by the complexity of the word used. Now, like a surface mount transistor would go into this pretty nicely, wouldn't it? It would just sit there on the surface, being small. I don't think I have a BC547 surface mount. I guess I could check. I wanted to use these though. This is more fun, question mark. Should I put this in on the other side of the board though? Because that'll get knocked around. If I put it in on the other side of the board, I basically have to flip it like this. Yeah, let's flip it and put it on the other side of the board. That way, our surface mount isn't put upon by all the stuff around it. Indubitably? You mean like what they do when you go under surgery? They intubate? So intuitively intubate? Do you get the joke? Okay, so there's my 3 leads from the transistor sticking up out of the other side of the board. Now I can solder them in. I can actually just bend this one in order to create that trace. There you go. Bada bing. Although that's going to make getting positive 12 volts in there a little bit harder. It's a clever joke. I appreciate it. No, it's not. It's a really dumb joke. I didn't have any follow through. Don't give me credit. I deserve to be punished for that. Normally, I would keep all the stuff that I have to do in my memory, in my mind's eye, and then I would forget things, and things would go horribly wrong. So doing this with the sheet up is much better. Yeah, my punishment is trying to get 12 volts into this mess. It's true. I'm probably going to have to go directly to this pad. We knew this would happen. I predicted this. I said it would be really messy. If I did surface mount on this, I don't know if it would be any cleaner. If I plan out the structures of how the things should look, it would be much easier for me to build. Who's got that kind of time, though? We're building this off the cuff. We're just doing this off the cuff, piecing all this stuff together, bit by bit, and getting it all working. From a circuit that we haven't even tested. No. What I'll do is when all this is together, I will take the positive 12 volts from right here and have a wire like here, or maybe even over here if I can keep this area open, and I'll just move it over to this pin. Now I would like it to pop up and go over, but it doesn't really need to. So it can just go directly to that pin. I'll just stick it through from the other side. Because yeah, now I've taken up this area with the 470 ohm. But this kind of thing happens. I mean, you got to make these little compromises all over. It would be cool if I had like a standard way to build these. And I guess the best that you could do for a standard way to build these would be to build them with like the surface mount circuit boards that have amplifier layouts already on them. A lot of scientists use stuff like that when they need to put together like a little amp circuit. You can get that together pretty cleanly. And it looks like the schematic. Which is helpful when you're dumb. Like me. I'm going to be just like Bother. Dumb. Oh, wait, no. 12 volts comes in. Oh, no. Negative 12 comes in over here. Yeah, this one is just the emitter. Because it's pin 3 is, so it's base, collector, emitter. The emitter is the one with the arrow in this particular circuit. That one goes to a 4.7, and then it goes to negative 12, which is over here. Positive 12 is over here. That goes to a 4.7, and it goes to the collector, which is in the middle. And then the collector doesn't get anything else. And then the base, which is the centerpiece, goes to a 2.2 that'll go to ground. So not positive or negative, it goes to ground. And it goes to a 3.3 that goes to the output of the op amp, as well as a 10K that goes to the input of the op amp, which goes to a 3.3K, which goes to the potentiometer, and it goes to another 10K, which goes out and around to our input. I feel like this whole thing could have been oriented, like mirrored, and it would have made perfect sense. I just decided to do it this way, and so I'm reaping what I sow. Me when I sow, smiley face. Me when I reap, frowny face. Those, I think, have been my favorite memes, and they're fully and completely dead at this point, but I very enjoyed the me when I reap, smiley face, and me when I sow, frowny face. Or no, it's the other way around. Damn it. I don't know why I find that so funny. It's like pondering my orb. Or the bling wizards. Is it bling wizards? No, it's a money wizard or something. Of course, staying off Reddit helps you really keep those jokes from dying. No one community will kill a joke faster. Do we need -12 anywhere else in what we're doing? No. Let's look over at the side over here. Okay, apparently center clicking. Unlike most CAD programs, MS Paint CAD does not allow you to center click and move around. That one goes to ground and 12 volts. That one goes to 12 volts. Let's see, we already got that stuff. Ground, ground, ground. Yeah, so these two connections are really the only entry for -12. -12, -12, and that's it. Huh, interesting. So yeah, I guess -12 is only going to there. In the past, I would wire up -12 by... Well, actually, let's get yellow for 12, black for ground, blue for -12, violet, no, violet for -12. Yes, violet for -12. Yes. Okay, yeah, let's get this going. So I'm going to do violet on this, and I'll just do boop, boop, and then we'll skip up and go up to -12, and then that'll complete all of the -12 connections in the circuit. Hey, how about that? How about that for progress? Jesus, it's already 4 o'clock. How far are we going to get with this thing? I mean, I like these streams where we build something and I have to reconcile, like I have to make peace with the fact that no matter what I do, these circuits are going to end up looking like they were literally exploded into existence. Like, I hate that that's what it looks like, but it's just how it's gonna be. I was considering leaving the LED hole on this one and then doing like some kind of an input tracking LED, but I don't know. I don't have that many circuit resources available to me at the moment to, you know, come up with how these things should look. Are we in the middle of a connector? We are. We're in the middle of a connector, so I got to go all the way to the outside. I don't even know if this will get us out. Let's check. Where are we? Here we are. Boop. Oh, good. I at least was smart enough to leave one hole on the edge for me to use. So that is going to go all the way up to -12. And this is the only customer that gets -12. So I can go out wide and waste a lot of spaces, or I could go directly over to it. I still need to fit all those diodes in here, and I thought this area was going to be good for that, because it seems like it is going to be good for that. But none of those go to -12, and I want to keep this thing out of the way. So for now, I will wire it. Yeah, I guess I'll do that. Well, that's going to use up that whole row, though. I really want this to be out of the way. Nobody else except for the potentiometer uses -12. And if I'm going to put all of the pins, they might go direct. They might have to go direct. Well, we can also sneak it up through this stuff. That's probably a good idea. Sneak it up and around, and then I can go... I need to go to there. This will be sandwiched in between the two layers, so if this is particularly sloppy, I can clean it up by just sweeping it under the carpet. I don't want it to take up any excess room. That's why I'm doing it this way. I'm going to solder directly to that pin instead of making it all organized. There we go. That, shot her, put her there. And then let's take a look at this on the microscope. Yeah, I'm going to do it like this because I don't want to take up any other space. I want it to just go directly to there. This is the only thing that uses negative 12 volts in this circuit. I find to be a little bit odd, but I guess it's biasing the negative or whatever. Get a little less stink on this thing. I can just pop that sucker right there. Oh, I didn't even solder in the interstitial pins of this stuff. Didn't I already tin that? No. And then tweezers. And I'll just pull that up from the bottom of the board so that when we work in that area, I'm not going to end up bridging any negative 12 line onto what we solder down, because this area is going to be used for the diode ladder. So I'm just going to pick that up for now, and we'll squish it down when we know more of what the board's going to look like. So that's a little sloppy right there. Let's get that solder done. And I don't want to solder anything to that the middle couple of pins, because these ThonkyCon connectors are supposed to have a hole underneath them on the circuit board in order to properly fit the 1/4-inch stereo jack. And the 1/4-inch stereo jack, or 1/8 of an inch stereo jack, is actually going to hit, 3.5 millimeter stereo jack is going to hit the board likely and bridge connection to that pin. So if I had negative 12 waiting for it right there, I could get into some trouble. Trouble. All right, so that means that the entirety of negative 12 volts is now wired up. So I'm just going to go ahead and, oh yeah, I did that. So we did this, I'll do the resistor itself, this, we did this one, but we don't have the positive connection. The transistor's in, and then we have negative 12 done there. We have this one done, and those are all the negative 12s. All of the negative 12, I X'd out the whole thing, but okay. Of course, you know, having this protection circuit on here means we're not quite, we're like 11.9 something volts. Yeah, see, that one's 12 volts to ground. Huh. Where am I going to fit all the rest of this crap? Oh, geez. Okay. Down here, we are at the 4.7K to positive 12 volts. That one is in a weird spot. But the positive 12 for that and this are all wired together, ready to go. We need to do this transistor here. And so this one has collector and base goes to ground. Wow, okay. Base goes to ground, and then the emitter goes up to the big boy circuit. But it's going to do that through 2 transistors that are connected to the big boy circuit. Boy howdy, how's this going to go together? And a kiloohm on that. Well, bit by bit. We're going to go bit by bit. I guess we're crawling our way over to where our resistor ladder is. Maybe we should build the structure of the resistor ladder, because all the other stuff that goes around it can go closer to where it's supposed to be populated. Like, we have to do this circuit here. That's got to be close to all this stuff. But then some of the elements, for instance, like the part over there that goes out to the connector, that would be here, down here. So down here, it could get the 4.7 NF and the 1K and then jump back over if there's not space. But ultimately, we need to wire this whole thing to a massive ladder of resistors and capacitors. The capacitors that we're using are 0.068 oof, and we need 4 of them. Luckily, I bought some of these weirdo precision, what are they, MKT capacitor? In NF values, so there's the MKT caps. Luckily, they've got the little thing right there. So 6.8 0.0068 common analog value, and we need 4. Which one was it? This one. 1, 2, 3, and 4. The Bic and Tick filter used up all of my particular value ones, all of my 47 NF. I'm going to have to order some more. 0.068, and these things need to be in between diodes that come down from a common area. We got 3 in a row with a 1K at the top, and we got a positive and negative rail. Okay, so I think what I can do for that is place them all not there. I guess we could do that over here, running out of space because of that circuit. If I do them near the edge, I don't know if that's going to be bad or not. So those will just drop down like that. And then at the top, I can wire the diodes. And then positive 12 volts goes through a 1 kilo ohm resistor at the top of the resistor ladder, and that can be right here. So those two would wire together, and then there would be a 1K, and then it would just jump over here. Of course, then after the 3, no, that's 3 diodes that need to go there. So 1, 2, 3. So we need to start a little lower. That's going to be hard to maneuver into because of the, well, if we cram it like way up here, I still need 2 more transistors in here. There needs to be 1 more transistor here, and then 2 more at the bottom of the resistor ladder. So I need to budget my space a little bit. And if we're going to have 3 diodes, 3 1N4148s, 1, 2, 3, going into this, and then 1, 2, 3 on these. Okay, so we'll put them there, line them all up in this section. It's kind of a weird circuit. It's interesting. Using the properties of the diodes as voltage-controlled resistors due to their microcurrent properties. I hope I have 1N4148s. I think I got a bunch of surface mount ones. It should be okay. Should I give them one hole of room to the side? I don't really think they need it. I mean, I am jumping in. Well, actually, wait, the op amp goes there? So 12 volts, those things, and then we're connecting like up here. And that has to go to here. Let's like cram them in here. No, there's not enough room. That, and then it goes all the way up to this. Well, 12 volts down through the 3, and then cap, cap, cap. But at this cap, I also need to connect it. I do need another hole on the other side, since that'll have to make a big jump. It'll make a big yump. It'll make yumps of us all. Hey! Pawn Theory for 7 months. Yo, Pawn Theory, thank you. Thank you, Pawn Theory. I hope you enjoy the content. I know it's a little weird what I do, but I try to do it fun. Yumping yaks. It's how Rob Oz used to say jump. He used to say yumping. And then he corrected himself because he's too embarrassed about his awesome Swedish accent, which is a very bad thing. I wish he loved it. Soldering that is going to be difficult. But we do already have our negative hookup. We just don't have grounds are going to have to come out through a wire and then string their way along. All right, so let's get these anchored. I guess that's where the ladder is going to live, because I have 3 diodes that go up here, 3 diodes interstitial, 2 wires coming out of that and going down to this area here. So that'll probably come out this way and down. So there will be kind of like a central run of where all the wires end up going. And then, yeah, I think that's the only place that I have to do this, which that's okay. I mean, there's a little bit of room there. We can make that work. But I'm also going to need 3 more transistors in this area. Ooh, that's a little bit difficult. That's a big ask. Well, we can move one of the well, can we move the transistors down? I don't think so. Because then there's all this other circuit stuff that has to happen over there. Maybe we can move some of the transistors over. One transistor has to couple up with this one right here. And then I've barely got room unless I put it like in a weird place over here, and then I've barely got room here where there's 2 transistors that do their thing, and then a circuit comes out from that. Dang it. This gets compact. Well, maybe I can just run the output of this out with wires to wherever the transistors are, like right over here. We'll have to see. This is going to be an exercise in really squishing things in. But that dog is just going at it today. She is too into the communications. I think she probably has to poop unless somebody took her out already. This is what happens when you get a dog. You start tracking her bodily functions and they become everybody else's business. Oh my goodness. You guys can't hear that. There's a whoa, 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 whoa. I want to bend the leads over, but I always find that to be kind of sloppy. Yeah, we're doing a bit of hardware. We're building a circuit. We're building a diode ladder, or a diode, I don't know, thingy. But it's a way of creating a voltage-controlled filter used in Moog hardware. I wish my brain glowed enough for me to be able to come up with this stuff on my own, but there are much smarter people in analog electronics than I, especially in audio engineering. I wanted to go into audio engineering. I thought that would be really cool. Did a little bit of it in Westchester for that AVIOM company, Aviom. Oh, so this one is the garbage people. The other one must have been friends, because I can hear the machines outside. Tracking collars for pets. It'll tell you where they are. It's called fuck! I just burnt my finger. Look at that, nice and warm. It's called an AirTag. It's the Apple AirTags. And you can actually get, I think, AirTag compatible software for the Android. But, I don't need to know where she is precisely at all times. Even my dog needs privacy every now and then. I have a Moog from that era. First 6 months we had her. Oh, wait, sorry, I'm skipping comments. Brink GG had a Moog from this era. I wonder if the circuitry's similar. Look for a bunch of capacitors and diodes that are in a ladder. They're just like next to each other. This would be in like a vertical configuration. Our cat had issues with number 2 for the first 6 months we had her, so we had to monitor that. Now, because of that, she comes in and tells us every time she cracks. I wish our dog had a very clear signal that she needs to go, because she'll march downstairs, come up to me while I'm sitting at my desk behind me, and just nudge my leg with her nose, which is a perfectly clear signal. She sometimes does that, but other times she will sit on a carpet upstairs and stare at you, and she'll just stare and stare and stare. I'm having a lot of trouble not having 3 hands here. Dear God, come on. What is happening here? All right, I think that worked. Ow, I can feel the heat on the other side. All right, now that they've got a little bit of solder on them, I can make sure that they're not all topsy-turvy. They remain more or less the same since back in the day. The circuit that was Moog inspired was the one that Moritz Klein did on the YouTube, and that was the one with the analysis, Moritz Klein's analysis, which is like super duper good. But this one, I don't know if Moog is mentioned anywhere. If Moog is doing the double ladder, the single ladder, or whatever. But I decided to build it because Haji will, and Haji was amazing. I should probably pop him a message and be like, yo, I've been building a bunch of your circuits on my on my channel. Ow, these are hot. Oh wait, how much they scratch, how much they poop. All that information is on the, what the? That's a lot of information. I know my family members would be absolutely jazzed at that, because then they could look at it on a chart and figure out whether or not she's actually scratching more than she should. And they would whisk her off to the vet at the first sign of, oh my God, she's scratching too much. It's like, she's a dog. She does dog stuff. Like, we don't need to worry about this so much. Ah, I'm like shaking weird. Probably need to stand up for a minute just to kind of reset. All right, let's get those leads chopped. Facebook posts about dog bodily functions. All right, I'm going to put my finger on top of these in order to snap them away so that they don't fly off and go short something out elsewhere in the shop. I'm not really good about doing this, but I have my stream computer is like open front. And so it's like this big, like, I should aim for it with these little bits, and then we can have a proper explosion. But then again, if it's the stream computer that explodes, we don't get to see it. Maybe briefly. Maybe you get just a glimpse of the explosion, but it is the computer that is streaming, so it probably is on the list of things that I would not like to have explode. But yeah, when you cut stuff like that, you put your finger on top of it and cut. I saw one of those DIY things where they closed the clippers, filled this with hot glue, and then split it again with a knife, and so you had this rubber pad on top of the flush cutters. I don't think these would hold enough stuff for that to be viable, but supposedly that holds on to the wire when you cut it. If I did make this in a circuit board, I could spread out so much more than I am right now. I don't need it. I don't need it. Let's find diodes. So I need 1N4148s, and if I remember correctly, I think I ordered a bunch of them. I'm going to stand up for a minute, though. Let all my blood clots get out of my legs. Theoretically, should be able to find a 1N4148 in one of these are all op amps. Those are all op amps. I should be able to find. I had a Moog Subsequent with a System 35 in a studio for about 3 years. Fun to play with. Yeah, that does sound fun. Oh, here's a low-pass filter. I could have just used that one. I think that's like an RF low-pass filter. And I only have one. There's an OPA 37. I used to have the thing that Louis has, the Korg. I had a synthesizer and a drum machine, the little portable Korg things, and I gave one to Julian and he sold it, and I don't know what happened to the other one. I should have kept it. I didn't know I'd be doing so much with music. Well, to be honest, I should have known, because the music stuff is very fun. Music stuff is very fun. And I'm learning a lot. Learning a lot. Oop. Looking for 1N4148. These are like thermistor controllers, resonators, and crystals. Okay. (4148) used optos. These are, oh wait, these are other opto isolators. All right. More optical isolators than you can shake a stick at. Those are all connectors. These are other specialized things like yumpers. And another thermal webcam. How did I not find the part that I'm looking for? Because it's right here. No. No. I must have passed it. These are V-regs. Oh, or is it on this one? It is. Let's see. So Schottky diodes, dual Schottky, 1N5819. That's still a Schottky. We need 1N4148. How big are these? These are very small indeed, which is good. That actually works for us. Okay, and I've got plenty of them. Good, 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 good. I knew I ordered some of these. Move this stuff up. Get this thing in place right here. Making a scary stack of these. If these fall on the floor, they eject almost all their contents. I've been a guitarist for 18 years. Damn. Briefly a session guitarist before I realized I was never going to make a living out of it. Oh, that's, I mean, hell yeah, talent, right? I studied piano for a little while, and I've done stage technology before, like, you know, devices that we need to use on production and stuff like that. Nothing too professional, but I've never been like, hey, I'm good at instrument. Look at me, I'm good at instrument. All right, so we need a lot of these diodes on this board. Let's go to the zoom in. That's not the right, okay, there's the camera. God, I gotta get a haircut. I look really weird. That's like the whole assessment of my character right there. Okay, tweezers. Hopefully these fit. Oh God, I gotta figure out what the orientation of all these in. The skill thing is the reason I stopped before becoming a session guitarist. Could you imagine in your life, you sit down, wait, this one already solder on it. You go back in. Like, I can't imagine rehearsing an instrument as part of your job. There was one of these like Canadian animation things, and I always thought it was very hilarious, but one of the bits was this pianist kept sitting down to practice and kept getting distracted by, you know, zany stuff going on. But actually the plus 12 is over here, isn't it? So I'm gonna have to go from there to here. Do I build it this way or do I build it the opposite way? And then I've got a little bit of room for the transistors down here. And I could put the 2 transistors here, and then their output could go elsewhere. That makes room for the 2 transistors, although I do have the same amount of space on the other side of it too. So I guess it's 6 of one, half a dozen of the other. So let's just build it up here. I kind of got to put them on the side here because otherwise they don't quite fit in the middle of these holes. So that there. This one, I've got to flip it. Damn it. Flip it. Now it goes on the other side facing the same direction too. I guess it's kind of a weird like push-pull thing. Of course, all this could probably be put into an electronic component that would be truly devastatingly small, but here we are soldering them. Here, I guess I got to solder the other side and then use that. Actually, maybe I should start over here. What's happening at the bottom of this? They go into, oh, there's a diode. Okay, so the first diode is here. 1, 2, 3. Okay, so we'll do that. Oh, these are going to be more annoying to solder, aren't they? Because they're going to be... Well, here's what I can do. I can take the solder away from them. I am going to take your power. I missed. And then I'll probably move that one. We'll just go up the line. What is going on here? It's trying to go to the middle of the pad instead of the edge. Probably shouldn't apply heat to the diode that long. Actually, these are 1 and 4148s. They're pretty robust switching diodes. Surface tension is a nightmare. Oh, come on. There's too much solder there. Okay, so let's do the next one up the line. We just keep going up the line. Friend who worked at a small record label. Some of the artists didn't have a regular guitarist, so I was brought in to play on 2 albums. It was fun. Couldn't keep doing it long term. It's tough. Another one of those industries where they expect you to, your love of the game to feed you. I just I just love the game so much that I'm gonna starve. Oh wait, I shouldn't have let go. Why did I let go? Okay, I'm gonna solder that one. All right, let's get into our groove and actually finish building this whole big thing. I guess we're definitely gonna work on this tomorrow, because there's no way we're getting too far with this thing today. But we've got a plan, and we've got almost all our stuff down. All the big things are kind of figured out. We can make this thing work. That'll be cool. Obviously, I wanted to get further with this thing, but I'm well aware that these things take quite some time. There's a lot of sort of figuring out how you're going to solve the problem before you actually solve the problem. It's a big puzzle. A big puzzle. Did I melt this thing more? No, I didn't. Okay. I thought I smelled plastic. That familiar plastic smell when you accidentally touch off on something you're not supposed to touch. The tweezers are not helping me out. Yep. Boy, that makes me want to redo this one. I guess it's fine. Nimble hands spend time building circuits. Okay, so now we remove the solder from these and we get 3 more diodes. It was me, diode. Yep. Ow! Wow! That almost drew blood. Believe it or not, the solder sucker has a sharp, not totally sharp, I mean the edge is broken at least, but it's got this sharp catch right here, which is how this thing holds back the plunger, right? And this thing goes in here and it snaps in, and the plunger's held back, and when you press this thing, it does a nice clean. That was still hot and I just put my finger down on it. It does a nice clean pickup of this thing, but when I was going to pull it back down, I got it a little bit of the way and then slipped and slammed my thumb into this hard edge. That hurt. All right, so diodes. Diodes. I'm glad I bought all these 1N4148s. They're one of the more jelly bean diodes, though. That sounded like it hurt. Could you actually hear? There's like a thud. I mean, a lot of the thud noise was just the thing taking in and out. I guess my reaction was pretty strong too. That might have tipped you off. It felt like it drew blood, but it didn't. Like this. Yep. Yeah, the tweezers don't quite fit in between these leads, and I need them to in order to place the diodes, so I got to kind of scooch them in like that. How does that look? That one looks terrible. It looks terrible. Hey, it's wiggle every time boop. I like that. I like that name. I got an off-brand solder rework station with a vacuum. It was cheap because it's not Weller. Yeah, the vacuum thing that I have is not Weller either. It's not a big name. It's just some rando name, like a white label product company name, but it actually functions pretty well. If I need to remove potentiometers from the modular stuff, it works very well for that. Any other desoldering I just do with the hand pump or desolder braid though. I don't often need to remove that many components from boards to justify using the entire pump-based solder sucker. This thing is also off by a little. Oh, I'm not going to be able to move it. I was dumb. Need you to scooch back a little bit, bud. There it goes. Good enough. All right, next diode. So many diodes. Flip it a boot. It's not, there's no R. There's no R. There's no R anywhere. Where are you getting that R from? Well, that is a sound that I make. It's not part of the screen name. Get in there, heat. What's going on? Is that going to stay in place? No, it's not even going to stay in place. Yeah, I'd be forgiven. Oh, I didn't add solder to it. That's why. I didn't actually solder that. Hold on. Hold on a minute. That's the problem. It was me. I was the problem. There you go. You know, when I came up with the moniker, I wasn't even thinking Winnie the Pooh at the time. But apparently, maybe that's why I'm not getting a lot of viewers. People are afraid of getting in trouble with the state. Well, either way, the origins of it was that, just the British phrase. I wasn't thinking Winnie the Pooh when I made the screen name. And I was told that it fits pretty well with the whole, whatever the hell I'm doing. Whatever the heck this is, it's working well for the moniker. Oh, bother. Pen name, screen name. We called them screen names back in my day. On AOL. MySpace wasn't even a thing then. Did I drop the diode or did I never pick it up? I don't know. I don't know which one it is. So I have absolutely no idea how this works. I know some of the details of what it's doing, but not enough to really comment on it. It is a diode ladder. You're using the diodes as voltage controlled resistors due to their microcurrent properties. When did he buy what? Timberlake bought MySpace. Well, he also indirectly created YouTube. Indirectly, I mean, the whole reason that YouTube exists is because of the Super Bowl Janet Jackson slip. I'll just say slip because I might get in trouble for naming body parts. It's really unfortunate, the reality that we live in that's controlled by advertisers in shitifying everything. But yeah, it was due to a wardrobe malfunction that didn't really seem like that much of a malfunction, to be honest, because she kind of premeditated the entire thing. And they definitely, I mean, you got to rehearse for stuff like that, right? So I don't know. But apparently her career ended there and his didn't for some reason. But part of that whole thing was that, like me in college, watching that on TV with all my friends, we went, wait, what? And then we were like, there was no way you could, it wasn't on like Newgrounds. You weren't able to find a video of it. So they said, hey, why don't we make the single most ridiculous data storage application on the planet, and we'll make it like public television. You can upload whatever video you want. And then eventually it became the monster that it is today. Newgrounds is so good back in the day. Hell yeah. No, it was before 2011. Yeah, but I mean, it wasn't even, it didn't even show anything. It was a piece of jewelry that she was wearing. She bought that specific piece of jewelry for that. Pretty nice piece of chaos. It's pretty crazy. All right, I need 3 more in line. Really, I could go like 1, 2, 3, and then it would just be right there. Actually, maybe I should, oh wait, no, I can't do that in both. Well, I can go down. I can go doot, 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 and then doot, doot, doot. That doesn't really work. Doot, doot, doot. No. they have to meet up at the same location, so they both should be 1, 2. No, that doesn't work either. 1, 2, 3, and then we'll meet up here. Yes, so 1, 2, 3, 1, 2, 3, and they're here and here need to connect the one. We're pretty much in that neighborhood anyway. Okay, so that's how it's got to go. I need more solder on this. You just stay right there. Nice to be able to spread out on a circuit board and make everything nice and clear. Not exactly what we can do here. Also, I think I need the outside channels to get wires in, because this where we are right now is where the yeah, this is where the op amp hooks up to this circuit. I wish I was better at finding the good stuff on Newgrounds, because there was a lot of great stuff. And some really terrible stuff. But terrible funny, which is always good. Terrible funny is always amazing. Yeah, it's got to be up like this, otherwise it doesn't fit. There you go. Another diode, Garçon. Spin that around, drop it down, flip it. You should all be saying ah to us. Or no, HV. You should all be upside down. You talking about Bebo the cat? What? There's a lot of stuff that's permanently lost from Newgrounds because the projects weren't good enough to move over to YouTube or to, you know, some other site like itch.io. They weren't good enough for that. And the creators are like either not involved or dead, or they've moved on with their lives. A lot of the stuff from Newgrounds has been, you know, slowly migrating with the death of Flash, but people just won't work on something that's, you know, frankly not worth it, but funny bad, which is really an unfortunate loss for the type of people that like to scrape that kind of content and find the really stupid stuff to show everybody else. Me. What, is Quap dead? I didn't think Quap was dead. At least that creator's moved on to making new stuff, bigger and better. What, Quap was a Flash game. I remember Red Letter Media playing it. Oh, the OG version is dead. I don't know if they were playing the OG version. They might have been playing like a Steam version. Could you buy Flash games on Steam? I guess they put it in like a wrapper. These are all misoriented. Quap was created by, believe it or not, an Australian Flash animator who created this wonderful game where you control each individual arm and leg on a jogger. And it was one of the most frustrating and hilarious stupid games that you could play back in the day. Back in, God, I don't even know when. Google it, greatest game of all time. Yeah, it was like, you know, laugh until you hurt kind of game. I remember Rich Evans playing that on stream. That was a long, long time ago, wasn't it? Because those dudes stopped streaming in like 2016. Visibly ages in front of his non-Zoomer audience. I gotta get those Zoomers into my stream. That'll make a career. I don't think they do electronics though. Yeah, it's the same creator as Getting Over It and Hard Climb or whatever that new one is. We had one where you're climbing up the side of a thing. He's made a couple pretty good bangers. Is that what it's... I thought Only Up was a different one. What's the one that borrowed all the assets? That's a different one. But it's whatever that bald-headed freak player model he has in every one of the games. And then, oh, that 1K is not going to want to sit there. Yeah, put it here. All right, diode ladder. Jeez, what a thing that is. Everything's oriented weird. I guess what I could do is put tape on the other side and then use hot air to heat it all up, and everybody would kind of, surface tension would kind of move everybody into position. I'm going to leave it the way it is, though. Leave it the way it is. I think it's fine like this. Let me see. If I do down in this direction, our positive voltage is right here. So I want to pretty much pick it up right here. And I guess I could get a wire in there, there, or there. So I guess that'll work. And I'll put a 1K resistor here, and we'll just bridge that. So 1K I have right here. Easy peasy. Yeah, I think I'd want to wait to do power and ground and negative voltage. Well, we've already done negative voltage, but I want to wait to do the others until the end, because they can slither their way around everything else. They're allowed to kind of wiggle their way into where they need to be. All right, and just a little piece of wire, any old scrap. I'm so ready for this to work the first time I turn it on. I don't think I have it in me to do hardcore troubleshooting on this thing. I don't know if I have it in me. We'll be able to. I mean, it should be pretty interesting the way this thing behaves, but I'm hoping it works just right off the bat. It ain't simple though, so I don't know. Come on, there we go. Okay, so that concludes this part of the circuit. We can knock this off. Bonk, bonk. All of this, but not the op amp yet. All of this, yeah, 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 and then all of this, and then this, but not the connection to 12 volts. Whew, okay, good progress. 6.8K is coming from the two legs of that last capacitor. Nice and hard to get to, huh? That would be these. So this one and this one need to come out of there and go all the way to here somewhere. I guess I need to build up this part of the circuit too. So negative 12 and positive 12 in the TLO74, and then we've got that stuff, and then we got the thing set up for resonance over here. So let's see. Where to even to begin? To begin is to even, and I cannot even. Minus and plus 200Ks. All right, so let's get 100 kilo ohms. Those are a bit harder to find. That one goes up to 37. So that's going to have the 4.7 and stuff like that. And then I got to go into the cabinet down here. I'm going to get 100s. Those are capacitors. I miss electronics. Garage is a mess after moving into the new house. Need to get myself sorted out. I mix fixing stuff. Yeah, the shop would be the first thing that I set up in a new place. I'd sleep on a cot. Actually, sleeping on a cot was really nice for festivals. I got one of those cots, and it lasted most of a couple festivals, but it was luxurious to have. Okay, so I need 2 100s. Yeah, if there was not a, like, in a house, I need a space where I can get away from it all, right? I just need a place where I can go and I can work on stuff like this and do the kind of stuff that we do here, because otherwise I get antsy. All right, let's see. So 100K into the minus, and from the minus to the ground, and this one, wow, this one really gets all of the voltages, doesn't it? Oh yeah, we already did these. We did this. We didn't do positive 12, but I've got that marked down below. We did this, and we did this connection. So a hundo on the feedback, and this particular thing, so that's pin 1, 2, 3, 4. So pin 1 is our output, pin 2, so that 100K has to go between these two. Let's just pull up the schematic just to double check that. I'm going to move this over here. Not the schematic, the data sheet. 1 is out, 2 is in minus. Okay, so in plus on this thing. In plus goes to a 100K, which goes to ground. That's going to be that third pin, and that goes to ground, not negative 12 volts. Because remember, this is negative 12 volts. But this is also ground. So actually, I'll put one, it'll be cleaner to put it out here, but then I'd need to do like a long wire to get over to there. Actually, that kind of works. And then the feedback is between these 2 pins, so we can move that out here. I guess I could just go here and then do boop, boop, and that'll connect all of our grounds together. At least for that short run. Okay, I have a plan. So the 100K that's going to do our feedback can go here. And that output, yeah, that'll go places. That goes other places. So a 1K and a 4.7 UF to output, and output is here. This is output. So we've got to go pretty much up here. We'll go up this little ladder right there to get to where we need to go. Oops, what's going on there? So gravity is not helping us out with this plated through board. With the stuff that's only got the stuff on one side, only got the copper connections on the one side, I can lay down a bunch of solder and it stays there. It's much easier than this stuff. You can see I haven't needed it to be plated through. There's no purpose behind that other than shorting out on a bunch of our components. The plate through does make us use this side, but it's not that big of a deal. Rather, the plated only on one side makes us use this side. Okay, so that's that one hundo. And then we have the other hundo that goes from this pin to ground. I don't know, maybe I'll just spread out and do it like that. But then what am I blocking? I don't think I'm blocking anything. No, I think I could do that. I could just spread out. I can just spread out. I can do whatever I want. I'm in control. Me. A lot of the other elements of this circuit are going to end up kind of cramped, I think. Since I didn't really plan this out. I probably could have planned it. Like with Fusion 360, I could have put the component, like import the 3D models of the components and tried to like locate them on the board itself, and then I could shift stuff over. It'd be a lot harder to really coordinate though, to be fair. That'd be kind of a funny way to do it. So that one goes to there, this one goes there, and I guess I might as well just wire that up. I can always rip it up if I need to. Negative power comes in, negative 12. Oh, negative 12 volts is already wired though. That's wired over here. So yeah, we're clear to just jump across these four. What up, Haystack? How you doing? How are you doing, my friend? We're building a voltage-controlled filter, ECF. And it uses weird stuff. And we're not going to finish today. We're probably going to finish this tomorrow. Oh, this guy's eating beans. Hey, everyone, this guy's eating beans. Did my soldering iron turn off? No, it's still on. It's still going. I don't know if I should cut this, and I should probably cut this and then run ground. Because it, like, ground also goes here, and I could come over here like this and then take a right angle and go over there, but I think maybe I need to cut it here just because my power and ground and stuff need to sort of run their isolated paths and not block holes. We want access to all those holes. Let's see, the other one is the resonance potentiometer. That goes to ground. And then on the, god damn it, on the center tap of the resonance, I'm like cutting into my vise instead of the thing that I should be cutting. Damn it! I hate it when it falls like that. Come back here. All the way back up. All right. Let's get that soldered, and then we can do some of the other connections. If I really was a freak about doing this electronic stuff with you guys, I could have planned this all out in CAD and had it all ready to go. Bigger the glob, the better the job. Heard that somewhere before. Let's see. So we have signals coming out of both of the ones that I want to wire at the moment. And I guess I can use this area here to put both of those. This one can go up and over to there with just an exposed wire. Like tin this. Dan, where are you? Where are you? I gotta. The problem with holding this wire close is that it gets hot very quickly. It's uncomfortable. It can actually burn you, but it's mostly just uncomfortable. Get some solder on those pins so I can solder to them. All right, ROAG, thank you for hanging out. Good seeing you. Hearing from all my friends. My friends. I'm going to drop a little bit of solder on these so that I can actually stick stuff to them. And then we will go and do this. Right here. There we go. Now I use the pin tool to come out and bend. Where's the pin tool? Pin tool. There it is. It's right under my hand. It's literally holding my hand over the pin tool, and I didn't notice it there. Like that. Then we will clip it. Oh, it's cheers brother, not bother. Like that. Solder that down. Might want to coax it to be just a little bit further like that. Where's all my heat? Well, still active. So I got somebody coming in here saying, this looks like shit. What's your problem? That happened to me once. Somebody just came in and started insulting my work. Like, dude, you try it. In this amount of time with this amount of people watching. Like, come on, I don't need that in my life. I forget when that was. That was a long time ago, I think. I mean, the alternative to it looking like shit and doing it this way is to build a circuit board, which is not all that unattainable these days. It's very easy to do. And it is a constant consideration about whether or not I want to build this cheap circuit in CAD first and just have it be nice and organized and laid out properly, which is what we did with the VCO. I didn't build it on a perforated prototyping board, but this filter is a little bit simpler. It uses transistors and stuff, and it doesn't have like a brain, doesn't have a Raspberry Pi on it, so I figure doing it this way is, you know, perfectly fine. But I don't know. You always think about it. This will be our output path from here to here. So we'll go directly out of this and then pop a right angle turn and head down the highway to our inevitable output. Wait, why is the one pin? Oh, it's 1, 2, and then 1. Yeah, and then these 1, 2, and then 1. Okay. So that transistor circuit would probably work better with surface mount stuff down here. I don't know if I have the BC547 equivalent in my surface mount transistors. I bought a little kit of them, a little book of them, but it had weird values in the book. I don't think they were quite the Jelly Bean audio level transistors that I had expected them to be. So here to here, like a saw, solder this thing in here. This is perfection. Blockchain, go back to your microcontrollers. Oh, wait, not you. Wait, you're the wrong person, Blockchain. Hi, Blockchain. This is not perfection. This is ugly. For some reason, I thought you were Ben Gizmo, and my brain, the neurons in my brain did a weird, like, pop shove it. As long as it works, that's what truly means the most. Well, yeah, I mean, yeah. Yeah, as long as it works. But there's very little chance this is going to work perfectly the first time. I've been lucky enough and skilled enough, I guess, for many of the circuits that I build like this to work perfectly the first time. But with anything analog, it just does not function properly at first. And I don't know what it is. I think it's me. I think I smell or something weird like that. Our first stop is a 1 kilo ohm resistor, and that also branches out into other circuits. So we have a little bit of room here to function if we need it. That's not really going to cut there. Oh, wow, it did. Okay, I guess it's cold welded. It's not actually soldered in, which is fine. We're going to go over that again. But now I need a 1K. My butt hurts. I've been sitting for too long. All right, let's grab this right here. Get rid of the excess. Got a little bit of room there for the 1K. I had to cut back the wire. As long as I can get it to actually flip over. Oh my God, it worked. Oh my God. Oh my God. Come on. So which one was this? This one goes to ground. We're going to have an entry here and here for the resistor ladder. And those will have to go to 6.8 Ks. And the 6.8 Ks I could do here. I could put them here and here, but that's going to eat up all the area that I had over here to work with this stuff. Did you mean to flip that plus 10? I pushed down on it with the soldering iron. Usually these things just kind of like flip themselves in weird ways, and whenever I try to flip them with the tweezers, they end up falling and flipping again. One of my big tweezer moves. Hold on. Let me just get this thing soldered in place. I need to add solder to both ends of it. Like a lot. Like a lot. Of course, this is using up a lot of good space. I probably could have popped over and down. Am I going to need to pop over and then go down this way to there? Well, let's keep it out in the open. It'll be fine. I don't think the world's ready for that level of compact. So the big move that I do with the tweezers, and let's see if we can find a 4.7 microfarad capacitor real quick, and then I can show, well, the 4.7 microfarad capacitor is not really going to show off that move very well. My big move is when you're holding something in the tweezers and you need to flip it, you do this without losing grip. Just like that. And that flips it. It's a good thing to learn. It's not that hard to do. Okay, so what the heck is going on down here? I need caps. Oh, I crushed my balls. That hurt. 4.7 oof. Is that 4700 puff? I don't think so. 0.1 uff is 100 nuff. I didn't do NF on this thing. I really should have. 2.2, 10, 100. I don't really have 4.7s in here. I gotta find one. I learned so much here, that was efficient. Hey, you know. Maybe someday you'll be as cool as me. Be able to flip your tweezers around like it's nothing. I may have used up all the 4.7s in here. There might be some ball bearings in the bottom of the drawer. I have that in those drawers over there. 4.7, 475K. 102. 474. 475. Hey, I've actually got one left. Couple left, but don't be like me. Don't crush your balls on the stool unless you're into it. I don't judge. Yeah. Okay, 4.7. So that one goes to the output. Why are you looking at me? Stop looking at me. This one's a big boy, so I'm probably going to jump it over one row. It's such a weird face. Stop making that big face. Doon, 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 doon. It's an Aphex Twin thing. You wouldn't understand. You're not into good music. What has Twin been up to lately? Just retired? Driving his tank around a French town? Who knows? Partying with Daft Punk? Didn't Daft Punk do some stuff recently? Didn't they get bored? Kind of like Orbital did. Orbital retired, and then they came back. I just don't know what to believe anymore. Are you making music? Are you not making music? You got to be clear with us. So this is output, which sits below the CV. Yeah, this is correct. Okay. This is where I wire things backwards because I'm disoriented. If I really want to be disoriented, I'll say I'm disorientated. But you don't disorientate. You don't orientate things because you want to sound weird. Did Robert really make that? Sounds about right. He didn't. Okay. It looks like one of his. I would believe you if you had gone with it. Oh, now you're maybeing it. I never get a clear answer for anything. You're always like this. Just like your father. The flux like blew up when I okay, all right. Just need this jump right here. I could have butt those up against each other and then done a right angle with the wire, but I don't know. This is a little bit clearer as to what's going on with the circuit, so that I can look back on it later and observe my work. It's good to spread out when you can. I don't know if I can, but we'll find out. Did I just slice off part of the resistor? Holy shit, I think I did. I came off of that wire with so much force that I sliced off part of the resistor. I just cut this entire corner off of the resistor here. I gotta put a new one down now. Which one was that? That was 1K. I've got tons of those. The bin is even still open for them over there. I can't believe I brutalized that poor resistor. Oh my god, I'm a monster. What have I become? Blockchain, hey! Thank you for subbing. What you doing over there? Always learn something new here. Great production with the cam setup. Thank you very much. It's the only thing that I've got going for this show. I'm happy for you to notice that. Yeah, the production quality I wanted to keep very, very high on this, and I've learned quite a lot through both YouTube and friends that are in the industry, well, similar industry. They're in video stuff, and yeah, I try to keep it nice, because I don't know, I get irritated when I watch somebody stream, and it's like, I know people can only do so much as they can do, right? You're not about to put hundreds of dollars into equipment. Then again, I use Logitech webcams. These things are no more than 60 bucks each. But when somebody doesn't, for instance, spend the time, because it does take time, you have to actually sit there and do this stuff. Nobody takes the time to actually like balance their audio and get it all within a nice range of each other, and make sure that you're not clipping. And yeah, I can never see so much close up anywhere else. Well, this was a pretty happy accident, and I've been doing a little bit with evidence photography, okay, so the country that we were working with didn't have like the same chain of evidence that we do, so we were on kind of a modified FBI evidence chain thing, but we did a lot of macro photography of things, of evidence type objects, and so I took a lot from that and applied it to this stream. Well, one thing you get here is unbridled failure. I fail at stuff often, and I don't want to hide it, because a lot of these streams, everything, or a lot of the, not streams, a lot of the like YouTube content, everything seems so easy. It's like, oh, I could do that. I could do that easy. Well, no, you can't, because they're not showing you all the failure. The input has to go to what? What does the input have to go to? Oh, the input almost immediately goes to a potentiometer, so we can mess around in this area if we need to. But then it has a bunch of components that go to a, what do you call it? Transistor. Okay, so we can pick up on that later. It is, oh geez, it's closing time, it's quitting time. Yeah, so let me mark down what we just did. I hope the cases are closed. You know, it's all in a warehouse somewhere now. It's in that Indiana Jones warehouse. What's the name of the board? I've been messing with Arduino breadboard and wondering how to make more permanent things. Perforated prototyping board is a way to make more things, more permanent things, but nowadays, circuit boards, entire circuit boards are $5 for 5. And you can do that within the country if you're in America. If not, you can get them from China. There's a little bit of shipping fee. For $20, you know, I can get 5 boards of this quality, and they're like perfect. You can't see from there. So it's hard to tell people how and why they should do perforated prototyping boards, because that's what these are. These are perforated, plated through prototyping boards. The plated through part is not necessarily the emphasis, but you can cut these up and you can build all kinds of different circuits on them. One-off prototypes, that's great. It's taking me 2 streams to build this. It would have taken me half of that amount of time to design a circuit board in Fusion 360, and then I could, you know, I have the front panel and everything, and I'd have room for all the stuff inside of it. So it's hard for me to say that you should know how to do this. The only reason you should know how to do this kind of working stuff is so that you can inevitably repair the circuit board that you've ordered and do little solder bodge jobs on it in order to get stuff working again. That's where this skill comes in. But that's it nowadays. That's the only place where this skill comes in. You can otherwise just spend a little bit of time in CAD and have everything be so much more accessible. And if you do it right, you could actually spread things out so that there's an ability to like repair stuff on the fly when you get the circuit board. The whole process used to be napkin. Where did my napkin go? Napkin with a drawing of a little penis on it. That would be, yeah, that's right there. I guess that kind of got lost in the fray. We'll just do this. Oh, wait, you know what? Yeah, we can do it. Here's a good spot. So napkin with a little penis drawing on it. Then solderless breadboard where you just stick the stuff in with the leads. And if you have the parts through hole, you could then go to perforated prototyping board and then from there design a circuit. So basically in this order. Doot, to doot, to doot, to doot. Nowadays though, cut this thing out entirely. You can just go from here to testing, vetting out your circuit, building this, and if you screw up, you're out $5. And then once you get the circuit board, you have to build it and make sure that it absolutely 100% works before you do a revision. But so this is perforated prototyping board. It has 1,001 uses that aren't, you know, building an entire circuit on it. Most of the time I'm using it these days is when I have to interface to something. Like if I need to press 4 pins onto something, I can do that. Or if I have fragile leads that I can then put to a pin header and then put leads on it, I can do that with a perforated prototyping board pretty easily. So that's really the big use of it instead of what we're doing right now, which is building a permanent surface mount circuit on top of the perforated prototyping board. But it's a good skill to have, and it looks nice on camera. I just wish this was a little bit more organized. Why are there so many spikes? There's like stuff sticking up and poking me as I'm trying to explain this stuff to you guys. Why is that sticking up so much? What is that? The heck? Oh, that's one of the leads of the transistor. No, it's okay. I'm winding up because it's 5:30 for me. Quitting time. Oh man, right when I try, somebody comes in and they know exactly what I'm doing. Yeah, that's a ladder filter. Have you messed with one of these before? We're going off of a Hajiwo design, and it's a diode ladder he did in 2021. Hajiwo is a YouTuber that makes a bunch of very cheap modular synthesizer stuff. And I stumbled upon his YouTube by a recommendation. It's 5 o'clock somewhere. Yeah, here, motherfucker. Yeah, but no, long-time synth nerd. I'm a new synth nerd with an old synth nerd friend. The old synth nerd friend has been after me for 20 plus years of our friendship to get me to start building him a synthesizer. He once wanted a violin case, but for me, in order to learn all the weird stuff that I can do, I need to know how these things work in the first place. So I found out you can just buy the circuit boards for these. And when you buy the circuit boards, they're like, good luck, asshole, have fun, don't ever contact anyone involved with the circuit board. And I love that. I love that because that challenge is to then build a functional module with something that told you to basically like, don't look for help from me. This is a Bic and Tick voltage controlled oscillator. I have not gotten this to work yet. I've had terrible luck with analog. But what I did is it was one of the larger sizes of modular synthesizer, and I basically broke it over my knee. I basically broke it over the edge of the box and have soldered wires between the two boards. I want to redo this with magnet wire because this doesn't work. Some of it works, but a lot of it doesn't. I basically took a picture of the board and marked off in red where I snapped it in half and then soldered wires across that so that they can go to where they need to go. But I have to revisit this and fix it. So, you know, things like that. Crimes and ornamentation that I call crime. Finding the microcontroller for it. I thought this Teensy 3.2 was dead. We put crimes on it and it works. So now I have a crimes module. 3340 VCO, That's an ASIC that does all the work for it. Stuff from what is that called? Whatever. Anyway, so yeah, I've been building this up for quite some time now, and we've had a lot of really good streams on it. DeWalt should make a specific market in the drill screwdriver option. What are you talking about? So yeah, anyway. Oh, you know it, it's switch capacitor? Yeah. The square wave signal in it is working and nothing else. But we're trying to make, right now, we're trying to make a Hajiwo circuit, and Hajiwo makes stuff on the cheap. Hajiwo was recommended to me by SpeedyCat after I spent a lot of money making the stuff that I have now. I love this philosophy of making stuff sort of on the analog and affordable and sort of more concept oriented, and it sort of teaches us all the different elements of a modular synthesizer. So, I mean, I'm probably going to need a sequencer, but we'll keep on moving with this stuff. We're also working on Burn the Subs, which is my XY laser table that's mounted to the wall. You've also seen the channel. You're more up to speed than I am on this, because I was listening to another YouTuber that I don't have up right now, but it's I still have it open. Oh, Moritz Klein, which is, I think, Erica Synths he works for now, but he's done a lot of really good videos that explain sort of the logic behind what all the components are doing in these circuits. And I listened to his diode ladder explanation, so I kind of have an idea of what it's doing, but I don't know how it works. I have been trying to figure out exactly how this works, but it is so boring. I think I almost fell asleep when I was watching it, because it's all very low-level stuff, but at the same time, I'm like, I already know about that, and then I'll miss something that's explained there. But we started to build a Hajiwo circuit, and then I decided to take it into building a PCB instead of actually making it on the perforated prototyping board. But I figure I owed you guys a perf board build, and so this Hajiwo filter is just what I need. I need some filters. So we're putting that together. We're done a pretty significant amount of the circuit. I mean, things are going to really start to come together tomorrow, because we need to, okay, what do I have here? What do I have so far? We didn't mark down what we did. We put in this 100K. We did this whole path here. Here, let's do this way. There we go. Now you guys can see a little better. We didn't put in this 4.7. I should have gotten another one out. We didn't put in any of the 6.8s, but I do have the 100K, but not to ground. So we stop there. Did I connect that to ground? Oh, well, I connected it to the other one that's not connected to ground, so we'll just leave it like that for now. We'll definitely remember that that's like that, right? Yeah, why wouldn't we? We have a little bit of space for the transistors that go to the bottom of the ladder, these two down here. And then I've got a little bit of space for the other transistor. Well, the one transistor is right here. No, where is that thing? Where do we put that thing? I guess we put that thing there that time. So we've got room here for another transistor circuit, I guess. This was previously drilled out for a switch. Oh boy, we got a lot of circuit that's got to go into not a lot of space. So the attenuator can drop in just about anywhere. So wherever we decide to put this transistor, we'll put the rest of the circuit, and then we'll drop in the signal from the attenuator. All right, good session. I think we've got a lot of this thing down. We just need this stuff, and then this, and then we'll be good to go. We'll be able to test it. So there's a bit of work to do, but we've got everything laid out now. We've got everything in front of us. We're ready to hit the ground running tomorrow. Thank you guys for dropping in on me here. Oh my God, I got like no viewers right now. Well, here's the end card. The people who are here are very, very dedicated and awesome people. Here's the end card. There's all my information. I will catch you guys on the flip side. Same bat time, same bat channel. I'll be here tomorrow. I start at 12:35 Eastern Standard Time. No, we're in Eastern EDT right now. Whatever. Whenever the clock says 12:35, I'm on the East Coast. And we'll hit the ground running with this stuff, and we'll hopefully get it all sorted out. I will catch you then. Be back tomorrow in approximately 19 hours, 6 minutes, and 15 to 12. I don't know. I'll catch you guys later. Have a good one out there. You guys know where to go. I'm not going to raid anybody today because I have an embarrassing number of viewers. It's not embarrassing. You guys are awesome. Catch you later.